Hello students, welcome to the class. So today we'll continue with this day 21 of this JEE 40 days crash course, and we'll start the chapter P block elements, right? So we will try to cover from group 13 to group 18, okay? So moving on, this is our disclaimer. What are the topics that we are going to cover today? So we will cover this P block element in 3 days. Now in the first part, we will see the introduction part. Then after, we will see the common properties which shows a periodicity in case of P block elements. Then after, we will move on to property of hydrides. What are hydrides? Basically, if an element is making a compound with a hydrogen, we call them as hydride of that particular element. Then we'll start with the group 13. So this is the first group of your P block, which involves your boron family. Then after, we'll move on to preparation, properties and uses of boron. And lastly, we will see the preparation properties and uses of aluminium. Okay. So this is the thing that we are going to cover today. Remember, we will cover this topic in 3 days. So we will try to move from group 13 to group 18. Now, starting with the introductory part of this P block element. Now, as the definition says, it's very simple to define the P block element. If the last electron of that element is entering the p orbital, then we name it as the P block element. So we have two groups of representative elements. First one is your S block and your P block. Okay, so in S block we have two groups, which is group 1 and group 2, and in your P block we have this 13 to 18 group. Now moving on further, there are 6 groups in total if we count from 13 to 18, and their valence electronic configuration will have a general formula of ns2 np126. Now this general electronic configuration is only exception for helium, because in helium the outermost electron goes to the s subshell, but still it falls in your P block elements. Okay, so we counted it in the 18th group. Next, what is inert pair effect? So this is a very important effect which is seen in case of P block elements. And if I try to explain it in simple terms, so whenever we move from first to third period, what will happen? The size of the atom will increase. Okay, you know it very well. The size of the atom will increase. As a result of that, your last electron will be placed very away from the nucleus. And in between the last electron and your nucleus, there will be a bunch of electrons present. These inner core electrons, which are uh, trying to act as a shield between your last electron or your valence electrons and the nucleus, prevents your electron from being restricted. Okay, so basically, if you consider the lower group, lower periods, we have this D block present in between. Okay, or D subshell present in between. This D subshell have a very poor shielding effect as compared to your S and P subshell. We know it very well. And why is it so? It is because of the diffused shape of the D orbital. Now, as a result of this diffuse shape, it will show a very low effective nuclear charge, and hence the electron will be pulled very strongly. Okay. As a result of this, you will see that ns2 electrons are very closely bonded to the nucleus, and hence they cannot be donated. So again, I am repeating it, it's very important. So if I try to put it in simple words, basically the outermost shell, which is your nth shell, its s orbital electrons cannot be easily donated because of the poor shielding of the inner core electrons which are present in d orbital. Now as a result of that, your +4 oxidation state is not that much good for the lower period elements of this group. Got it? And this effect is known as the inert pair effect. For example, if I take the tin, so tin has a more tendency to go to the +2 oxidation state rather than +4. Means it has a lesser tendency to donate its electron which are lying in its s orbital of the outermost shell. Okay, and why is it so? It is due to the poor shielding effect of your d orbital. Now moving on to the general characteristics of this p block elements. If I talk about the non-metal and metalloids, then these are the only things that are present in your p block elements. You won't see a metal. Metals are only present in s block, in d block, and your f block. So in s block we have alkali metals and alkaline earth metals. In d block we have transition metals, and in f block you have lanthanides and actinoids. But in your p block you will always see a metal and a metalloid. Sorry, non-metal and metalloid. Got it? If I move down a group, then the metallic character increases. It's very simple. It is because of the easy tendency to donate electrons, because now your electrons are present very far apart from the nucleus due to the increased size. So as we move down the group, the size of the atom increases, and hence the donation of the electron becomes easier, and the species which donates electron easily are a good metal. Got it? Whereas if you move from left to right, then in that case your non-metallic character increases, because here we are decreasing the size. Okay, so if you're decreasing the size, that will make it very difficult for donation of the electron. Now in between metals and non-metals we have this metalloids. So that includes your gallium, germanium, and your silicon. So they form a ladder. We have talked about this in the previous class where we saw the modern periodic table, and there we saw that what are the metalloids. So they are the elements which shows a property intermediate between metals and non-metals. Got it? I hope this is simple to understand. Now, especially the second period elements, for example your nitrogen or oxygen, they have a very strong tendency to form a p pi p pi bond. And why? What is the reason behind it? Because they have availability of p electrons only, or p orbital only. As a result of this, it has a high tendency to form multiple p pi bonds. Can we take examples of it? Yes. So we have carbon carbon bond, then nitrogen nitrogen bond, then we have oxygen oxygen, and then we have in between the atoms also, like oxygen and carbon. Here you can clearly see that there are multiple bonds present between the two carbons. Now this part can be a part of your alkyne. Similarly in alkenes also we see this double bond. In simple nitrogen we see multiple bonds between two nitrogens. Okay, similarly in oxygen we have two bonds between the two oxygens. Got it? So we can clearly say that second period elements has a tendency to show multiple bonds of p pi type. So there are questions in your exams that which of the given compound can form p pi bond. So you can easily say that these elements such as carbon, nitrogen, oxygen, which falls in the second period of the p block, are capable of forming p pi multiple bonds. Next, moving on to its covalency. So what is covalency? It's very simple. It is the number of bonds your element can make. Now it is seen that second period elements cannot expand its covalency, and the reason is non-availability of d orbitals. So d orbitals allows more electrons to be donated in them, and hence allow formation of more number of bonds. But in case of second period, you know it very well that the maximum quantum number possible is 2. Okay, we have seen this, that period can help us to determine the value of maximum quantum number possible in its electronic configuration. So for second period it will be 2. So therefore 2s and 2p are only possible, and hence no d orbital is possible. Therefore it cannot expand its covalency. Next, as a result of this, halides of such elements are not hydrolyzed easily, because during hydrolysis your OH comes to the vacant d orbital or any vacant orbital. There it donates its electron, and then hydrolysis takes place. But in case of your second period element, there is no vacant orbital which can be available for the donation of electron from your water. Yes, there are examples of it. You can take example of BCl3 or CCl4. if you try to draw the orbital diagram of this using the box diagram, you will clearly see that carbon has a completely filled subshell of S and P, and there is no further possibility of acceptance of electron from water. Therefore, it cannot be hydrolyzed with the help of water. Okay, so this is a very genuine reason for non-hydrolysis of this second period elements. Okay, now if I move to the third period, you will see that onward only forms single bond and can expand their covalency to the maximum, because now we have the presence of d orbital. Now if you consider the third period, that means the maximum value of your principal quantum number possible in its electronic configuration is 3, and for third shell we have 3s, 3p and 3d. That means d subshell is possible. If d subshell is possible, and it will be of course vacant, then it can easily form multiple bonds leading to a expanded covalency. So can we take an example? Yes. So we have S8 ALF63 minus. So here fluorine is donating electrons to aluminium's d orbital. As a result of this, it can make 6 bonds with the aluminium. You can't see such higher covalency for boron or carbon. See, for boron it is 3, for carbon here it is 4. But in case of your aluminium, you can clearly see a covalency of 6, which is very high. Now, your boron and your carbon, they both fall in the same group, but due to its availability of d orbital, you can form 6 bonds with the aluminium for fluorine. But since boron is lacking a d orbital, so it can maximum form a bond of 4. So BCl4 you can see maximum, but you can't see a BF6 minus. It is something which is never possible due to lack of empty orbital. Next, let us talk about the acidity and basicity. So, your non-metal oxides, they can be acidic or neutral as well. So, can we take example of your neutral oxide? Yes, we have examples of neutral oxide such as carbon monoxide, which is CO, then we have NO, then we have N2O. So, these are some examples of neutral oxides, means they are neither acidic nor basic in nature. Whereas metallic oxides are always basic in nature. So these are some very important points that I am telling you regarding the acidity and basicity. So what did I say? So non-metal oxides can form acidic as well as neutral oxides. Acidic means it can accept a lone pair or it can donate H+. And for neutral means they don't show any acidic or basic property. For example, carbon monoxide, then nitrogen oxide, then N2O. So these are examples of your neutral oxides. Whereas your metallic oxides are always basic in nature. Will you remember this? So it's very important for you. So moving on further. So we have some more characterization which is possible. This is known as your amphoteric oxides. So there are some metalloids which can form amphoteric oxides. What are amphoteric oxides? Very simple. Those oxides which are capable of showing both acidic and basic nature as well. Okay, it means they can act as an acid as well as a base. What are the examples of amphoteric oxide? So I am telling you the oxide which show amphoteric, and they are the only example. So if you remember them, you can easily solve questions on this basis. So what are those examples? So we have zinc, aluminium, SNAC, then lead, and then gallium. So I have a mnemonic to remember the same. You can remember it like this. Zinc, aluminium, SNAC leads to gas. So zinc stand for zinc, aluminium stand for aluminium. SNAC you can take SN, so that would be tin. Then leads to gas. So leads means lead. Okay, Pb. To gas. For gas we have gallium. So in this way, you can learn the name of all possible amphoteric oxide. And in a period, if you move from left to right, so if I talk it in general sense, the acidic character increases. So it's very clear. We have seen that non-metallic oxides are acidic in nature and they are present on the right hand side. Whereas your metallic oxide are basic in nature and they are present on the left hand side. So we can say that if you move from left side to hand side to right hand side, the acidic character increases. And why is it so? What is the reason behind it? Can you tell me? Anyone? Can you tell me why non-metallic oxides are acidic in nature? Is there any specific reason for this? So think about the general property of non-metals. Anyone? Can you tell me? What is the reason behind your non-metallic oxide to be acidic in nature? Why non-metal oxides are acidic in nature and why metallic oxides are basic in nature? So of course you know it that this is the thing, but what is the reason behind it? You just write it in the comment section. Anyone, can you tell me what is the reason behind for non-metallic oxides to be acidic in nature? So there is a very primitive reason for this. If you want, you can remember this, and it is important at the same time to remember the reasons as well. Basically, if you consider a non-metallic oxide, it is constituted of a non-metal and a oxygen. You know it very well that non-metals are comparatively electronegative as compared to your metals, and oxygen is highly electronegative. Now you have two electronegative elements combined to each other. Now that creates a species which is having an electron hunger, and the species which accepts electron are acidic in nature. Okay, so it may seem primitive to you, but this is the reason your non-metallic oxides are acidic in nature. Now you can think of your metallic oxide. So basically, it's very simple to clear it. So metallic oxides, what do? They are forming oxides by donating electron, because if it is metallic in nature, it will form ionic oxide most probably. Therefore, if it is ionic in nature, means it donating electron and forming positive ions. Got it? And these positive ions are eager to accept electron, and hence they are basic in nature. So to donate electrons. Okay, is it clear to you? So what did I say? You have a metallic oxide in which one is metal and one is oxygen. So as compared to non-metal oxide, which has a non-metal and oxide, the combination of a metal and oxygen is not that much electronegative, so it can donate electron. So they are basic in nature. Whereas a non-metal and an oxygen, they creates a combination of an electron hunger species, and hence they accept electron and are acidic or neutral in nature. Then in between falls your metalloids, and therefore they are amphoteric in nature. Remember what are the metalloids? Remember the name: zinc, aluminium, tin, then gallium, and your lead. So we have a mnemonic for it also. Zinc, aluminium, snacks, lead leads to your say, what was the last one? So what were the five amphoteric oxides? Can you tell me? So please give me the answer so that I can help you with the questions. Okay, if you have any doubt regarding the class. So can you tell me what were the names of amphoteric oxides I told you earlier? Anyone? Okay. So moving on further. So generally it is seen that oxides with higher oxidation state are mostly acidic in nature, and it's very obvious since they have a higher oxidation state, means they are having a greater positive charge and hence a greater tendency to accept electron. Therefore, they are acidic in nature. So these are some points you should remember. First of all, non-metallic oxides are acidic and neutral in nature. The only examples of neutral non-metallic oxides are carbon monoxide, then NO and N2O. Examples of your amphoteric oxides, which are your metalloids, is your zinc, aluminium, then your tin, gallium, and lead. Okay. Whereas all metallic oxides are basic in nature. And the last and important point is that if you are having a higher oxidation state, then there is a greater probability for that species to be a acidic compound. Got it? Now, next moving on to hydrides. So we have studied about the oxides. Next is your hydrides. It is seen that the basic character of p block hydrides decreases on moving down a group and acidic character increases. Now this point is something which is very important, and you will see question from this basicity part. So in fact there was a question in 2024 regarding this basicity. Yes, tell me your doubt. You can just write it in the comment section. Your doubt, you can just post it here. Okay. So why does the acidic character basic character decreases down a group and the acidic character increases? Basically, it is all due to your hybridization. So listen it very carefully. Okay. So if I talk about the hydrides, then there are some hydrides which are formed without hybridization. Now, what is the meaning of this? Take the example of H2O. Okay, so the hybridization is sp3. But if I take the example of PH3, which is a hydride of phosphorus, due to the large difference between the energy between your hydrogen and phosphorus, hydrogen is not capable of hybridizing the orbitals of your phosphorus. Therefore, it will not undergo hybridization. So, PH3 is not having a hybridized state. It is basically forming bonds with the help of pure atomic orbitals rather than hybridized orbitals. As a result of this, the lone pairs of your phosphorus are still present in the pure S subshell. Okay. Now, as compared to the hybridized orbital, which is your sp2 or sp3, the S subshell has higher S character, means they are present in S subshell, so it has a higher electronegativity. Got it? Therefore, it cannot be donated easily. So it all comes from the hybridization. What did I say? So phosphorus, which is having a very high energy state as compared to hydrogen. Therefore, hydrogen is not capable of hybridizing the orbitals of p, which is a phosphorus. As a result of this, the electrons are present in unhybridized orbital, and I would say unhybridized s orbital. Now your s orbital is highly electronegative in nature. Therefore, it is difficult for those lone pairs to be donated as compared to those electrons which are present in hybridized orbitals such as sp3, because sp3 will have some s character and some p character. So I would say if I say exact value, it would be 75% p character and 25% s character. You know it very well. S orbital are closer to the nucleus because of its spherical shape. So if s character is increasing, electrons become closer to the nucleus and are difficult to donate. So electrons which are present in sp3 are easier to donate as compared to pure s orbital electron. So this is the reason. Got it? Now if I talk about the period, then on moving from left to right, the acidic character increases. Next, here is a very important point. So, you would generally think that the size of arsenic is bigger. Now, it may create an illusion to think that your arsenic has a bigger size, so it can easily donate electrons. Because you know it very well, the ionization energy decreases down the group because electrons are now farther away from the arsenic. But the result is exact opposite. And as I said, what is the reason behind it? The reason is the unhybridized state of your higher elements or heavier elements. So your phosphorus and arsenic do not undergo hybridization. As a result of it, its lone pair are present in pure s orbital, and pure s orbital have a very high electronegativity and hence they cannot be donated. So it has a lower basic character as compared to NH3, where its lone pair is present in the sp3 hybridized orbital, which is having a lower s character. It is 25% s and 75% p. Then if I move from left to right, the basic character also decreases. Here also it decreases, and it's very simple to clear it. The reason is your electronegativity. Now you would ask, then why did you not apply this same logic to this? Because as you move down the group now, in that case your size is a greater factor. In a way, you are increasing the shell by 1. So that is a very huge difference in size. Here also the size is changing, but to a very minute extent. Therefore, the effect of electronegativity is very much significant because their sizes are comparatively same. But here the size is changing drastically. So here we cannot consider the electronegativity factor. Got it? So that is the reason we are taking different aspects in different cases. So it is basically dependent upon which group wise or period wise you are considering your trend. Okay, I hope you got my point. So basically, if you are moving from nitrogen onto oxygen onto fluorine, you are increasing electronegativity, and therefore the donation of electron from nitrogen, oxygen and fluorine becomes difficult and difficult. Next, talking about the thermal stability. Since your hydrides of your heavier elements are not formed as a result of hybridization, and you know it very well that overlap is done better by the hybridized orbital. Okay, you know it very well that hybridized orbital are much more capable of doing effective overlap, but you know that heavier elements cannot undergo hybridization. As a result of this, they don't form stronger bonds, and hence they have a lower thermal stability. Okay, so all of this is coming from the energy difference between your phosphorus and hydrogen, which are present at a very far distance from each other. Got it? Next, since the thermal stability is decreasing down the group, so your hydride of heavier elements will be easily broken, and they will be easily donating hydrogens. And if it is donating hydrogens, means it is having a greater reducing character. It has a greater tendency to reduce other species. So this slide that you are seeing right now is very, very important, and there is a high chance of seeing question from this slide regarding your P block. So it has three things. Okay, first is your basic character. Second thing, so basic character along the group and along the period both. Second thing is your stability of hydrides, and third thing is your unhybridized case of your phosphorus. Got it? Next, moving on to the properties of hydrides. Now we will discuss the third property, which is bond angle. If I talk about the bond angle, then this bond angle decreases. If you move down a group, this bond angle decreases, and again this result is also coming from the unhybridized state of heavier elements. So basically, due to unhybridization, your phosphorus has a bond angle closer to 90°. You may think that since it is forming in the family of nitrogen, so it should have a bond angle which is closer to your sp3 hybridized orbital. But since it is showing no hybridization or very less extent of hybridization to a very small extent or negligible extent, as a result of this, your phosphorus has a bond angle very away from this tetrahedral, and it is equals to 90°. And this point is also very, very important. You will see questions from this bond angle comparison. Now if this is the case, you can easily say that bond angle decreases down the group. You can also predict a secondary reason for it. Okay, so primary is the absence of your hybridization. The second reason is your charge density of your central element. So since your central element is very low in electronegativity, so the electrons are present far away from the central atom, and hence there is less repulsion. Okay, so they can be closer to each other. Now can we set an example? Yes. So H2O, H2S and H2SE. You can clearly see that the bond angle is decreasing here. We can take if the central atom belongs to the same period and have the same hybridization. Okay, then in that case the bond angle decreases due to increase in number of lone pair. For example, if you take from CH4NH3 to H2O, so here we have a different reason for the decreasing bond angle. Here the reason is of no hybridization. Here the reason is of greater number of lone pair, because it has a smaller size, therefore its lone pair will have a very high impact on the bond angle. As you keep on increasing the lone pairs, the lone pair bond pair repulsions count will increase, and hence the bond angle between the two bonds will decrease. So if CH4 is having a ideal tetrahedral shape, the NH3 will deviate to a smaller angle, and H2O will have an even smaller angle due to presence of two lone pairs. Got it? I hope this is clear to you. So these two slides are very, very important. Remember this. Okay, you will probably see a question from these two. Next, moving on further with this property of hydrides, we will talk about the boiling point. So this is something where questions are not generally asked from, but still I have put it here. So boiling point of hydrides are increasing on moving down a group. And what is the reason? Very absolute reason is there, the increase in the molecular size. So as the molecular size is increasing, the van der Waals force is also increasing because it is totally dependent upon the molecular size. Hence, there is a strong interaction. Therefore, your hydrides have a very high boiling point on moving down the group. But there are exceptions to it also. And what are the exceptions? The exception is directly coming from HF, H2 and NH3. The reason is intermolecular hydrogen bonding. You must have heard this term. So basically, if your hydrogen is attached to a highly electronegative element such as fluorine, oxygen and nitrogen, then it is capable of doing hydrogen bonding, which is basically an interaction between two molecules between their hydrogen and the electronegative element. Okay, as a result of this, these molecules are closely packed to each other and they are very difficult to separate. Therefore, they have a high boiling point. Now, this is shown by your first element in each group. Means this unique behavior is shown by first element of each group. Especially I would say for fluorine, oxygen and nitrogen. And the reason for this hydrogen bonding is, first of all, since it is the first member of your group, therefore it will have a small size and high electronegativity and non-availability of d orbital in the valence shell of the first element in each group. So due to this small size and high electronegativity, they attract hydrogens of other molecules towards them and they keep them together, forming a network of hydrogen bonding. As a result of this, it is very difficult to break the molecules apart and hence they have a very higher boiling point. So we will start with the first group, which is group 30. So this was all about the general introduction. We learnt about the general characteristics and then about the oxides and lastly about the hydrides. Okay. Now we will move on to specific groups. So first is group number 30. Clearly, this group is also known as the boron family and it includes boron, aluminium, gallium, indium and thallium. Okay, you can just remember this in a mnemonic, so it is quite funny. So bangan, alu, gajar in thala. So this is your mnemonic to remember the members of the boron family. Okay, now they are belonging to group 13 and they all have 3 valence electron in their outermost shell. But their properties are quite similar, but still they show a very large variance, especially the boron thing. Okay, so the first thing you have seen in the previous part where the boron has a lesser covalency as compared to aluminium due to its smaller size and unavailability of d orbital. Then next difference is that boron is a non-metal, whereas rest of the members are having a higher metallic character and they are almost metals. I would not say they are completely good metals, but they are almost metals. And you know it, aluminium has a amphoteric nature as well, and that is directly coming from the part that they are falling in the region between the metals and the non-metals. Okay, next some important properties are here. Suppose I start with the electronic configuration. So the general electronic configuration is ns2np1. So this is the way you can write it. So for ground state it will be ns2np1, and if there is a possibility of excitation it will show ns1np2. So this electron has jumped from the s subshell onto the p subshell. Got it? So these are some things regarding your group 13 element. Next, moving on to the chemical properties of the group 30. So they are capable of showing two oxidation states, +3 and +1. Now question arises, why +3? Again, the reason goes back to the inert pair effect. You know it very well that due to its poor shielding effect of the d orbital, the two electrons of the s subshell are closed very tightly. And as a result of this, they are difficult to release, and hence if you move down the group, as soon as the poor shielding effect dominates, your two electrons of the s subshell are difficult to release, and hence the stability of +3 oxidation state increases down the group. This is not seen for the lighter elements where there is no presence of d orbital, but as soon as the d and f orbital comes into the picture, as a result of this, the inert pair effect affects the ns2 electron. They pull it more closely to the nucleus and hence they are difficult to release. As a result of this, they can show +1 oxidation state. Now, as I said it earlier, the stability of +3 oxidation state decreases down the group and they are more capable of showing the +1 oxidation state due to the inert pair effect. Next, if I move down the group, of course, your inert pair effect will increase. Why? Because now we have more and more electrons which are coming from D. So if you consider the first one, which is 3D, there we have only D subshell. But as soon as you move to the next period, which is the fourth period, there we have 4D and 4F also. Okay. Now the shape of the F subshell is even more diffused and it has a very less shielding effect. So it has the least shielding effect as compared to S, P and D. Therefore, now the electrons are held even more tightly. And moving on to the next one, which is 5D, which is the fifth period. Here we have 2D orbitals and 2F orbitals. Okay, so 3D orbitals and 2F orbitals. Here also the shielding effect goes even down, and as a result of this, the stability of +3 oxidation state increases more and more. As I said earlier, so from the fourth period and onwards, the effective nuclear charge is increasing due to this poor shielding effect. Therefore, as a result of this, we have one more effect, which is the radius of gallium. And this is a very popular question in your competitive exams. So the radius of gallium is less than that of aluminium, and the reason is the poor shielding effect due to D and F subshell. So as a result of this poor shielding effect, the outer electrons are held very tightly or pulled very tightly, and hence the atoms shrink and they show a smaller size, which is seen in case of gallium and aluminium. So aluminium is having a size of 143 picometer, whereas gallium is having a size of 135 picometer. Now this is very drastic because now you are moving from one period to another period along the same group, but still your size is decreasing rather than increasing. Okay, so this is very, very important. Next, we have hydrides. So we already studied about the general properties of hydrides. We will move on to specifically group 13 hydrides. So if I talk about the first element of this group 13, boron, then boron exists as the dimeric form or in the polymeric form for the hydrides. So we have diboron as B2H6, which is the simplest dimeric boron hydride, which is known as diboron B2H6. Next, if I talk about aluminium, they form only one colorless solid polymeric hydride known as AlH3N, and this general formula is therefore alane. Okay, so the group of species which are having their chemical formula in this set, which is AlH3 whole N, are known as alane. Next, if I talk about the hydrides of gallium and indium, they are not that much stable. Now this is something which is already being discussed in the previous part regarding the phosphorus and all. There I said that the size between or the energy difference between gallium and hydrogen is very less, and as a result of this they cannot do a proper overlap. Okay, and hence their hydrides are very less stable as compared to the boron hydrides and aluminum hydrides whose energy level is closer to hydrogen. So basically if you look on the periodic table, it's very clear from that also. Hydrogen is having a very small size. It is present at the top of the table. Got it? As we are moving away and away from the hydrogen, your energy difference between the hydrogen's orbital and your upcoming or higher element orbital is increasing. Okay, it is increasing from moving from one period to another, and as a result of this, hydrides of heavier elements are very less stable. For example, of gallium and indium. Next, your boron, aluminium and gallium, they form complex anionic hydrides. You know as examples of those. So we have NaBH4. So we have BH4 minus is the complex anionic hydride. Similarly, we have LiLH4. Again, we have the ALH minus LH4 minus as the anionic hydrides, and then we have gallium H4 minus, which is the anionic hydride in LiGaH4. Okay, so you know these names, right? Now, here the thing comes. Okay, so it's very, very important as well. You know that your LiLH4 and your NaBH4 is a well-known reducing agent in organic chemistry. Okay, now you will say that your LiLH4 is a very strong reducing agent as compared to NaBH4. Why is it so? So the answers come from this trend that you are seeing. So as you are moving down the group, the stability of the hydride is decreasing. You know it very well. And as a result of this, your AlH4 minus is comparatively less stable than BH4 minus, because these two are hydrides only. This is the hydride of boron and this is the hydride of aluminum. So the stability of AlH4 minus is low as compared to BH4 minus. Hence, it will easily decompose to donate the H minus, and therefore it is a strong reducing agent. All of these are strong reducing agent, but as you move down the group, so LiGAH4 is even a stronger reducing agent. Moving on further, next we have highlights. Okay, so what are highlights? You know it very well. So highlights are something which are formed between the group 13 element and your halogen. Now your halides have a incomplete octet, and their covalency is, in most of the cases, it is 1. Okay, due to its 1 covalency, it is a very higher tendency to accept electron. As soon as it accepts 1 electron, it goes into a very stable state, that is your octet state, and hence they behave as Lewis acid. Got it? Now, if I talk about the basicity, acidity of this highlights of your boron, then you can see here, then Bi3 is having a higher acidic character, then the BBr3, then the BCl3, and then the BF3. You may ask, what is the reason behind it? Because in general sense, if I say the fluorine is having a higher electronegativity, so you will say that it will have a greater tendency to accept electron. Okay, so that would be the initial thoughts of you. Similarly, your chlorine is having a lesser electronegativity but is having a higher electricity than boron, so it should have a greater tendency to accept electron. But here we have a different reason to accept this acidic character order. And what is that reason? That reason is overlap. Okay, back bonding. Basically, these lone pairs of fluorine. Okay, so fluorine will have the lone pair, it will make one bond, and then it will have 3 lone pairs. Now, these lone pairs of fluorine can be donated onto the boron. Okay, so boron has a vacant p orbital, and into that your fluorine can donate electron, and this is known as back bonding. Now you will ask, your chlorine, bromine and iodine, they can also donate electron, they also have the lone pair, but the point is that your boron and fluorine are falling in the same period, so the energy difference between their orbital is very less, therefore they can easily share the electron between the fluorine onto the boron. Okay, and hence the deficiency of your boron is removed by the lone pair of the fluorine, whereas your chlorine and bromine, they do not fall in the same period, and hence they are unlikely to share the lone pairs of chlorine onto the boron, and same thing can be said for bromine and iodides. Okay, so this is also a very, very important acidic character, and the reason is the back bonding which is coming from fluorine onto the boron. Next, if I talk about the physical appearance, so BF3 is a colorless gas, then BCl3 is a colorless fuming liquid, whereas Bi3 is a white fusible solid. Now you will ask that why is this state changing? Why they are coming closer and closer to each other? The reason is your intermolecular force, which is your van der Waals force. So as you are going from BF3 to Bi3, you are changing the molecular mass drastically. So it is increasing from fluorine to chlorine, it is increasing. Then again it is increasing from chlorine to bromine. As a result of this increased molecular mass, they will have a high intermolecular van der Waals force, and hence they will have a solid state as you moved on to the Bi3. Okay, as I said earlier, the BF is capable of showing a back bonding state. Now as a result of this back bonding, you must expect that your bond order between the boron and fluorine would be 1, but in place of that it is 1.33, because now your lone pairs from fluorine is getting onto the boron to remove its deficiency in electron. As a result of this, there is not a complete transfer of electron and not a formation of complete bond, but a partial bond that leads to a bond order of 1.33. So what is bond order? It's very simple. It is the number of bonds. Okay. Next, talking about the oxides. So the oxides are something which are formed between the group 13 element and the oxygen. So their basic character increases as we move down the group. For example, B2O3 is weakly acid, then Al2O3 is amphoteric, and other oxides are even basic in nature. What is the reason? It's very simple. As I said earlier, that boron is the only non-metal, and if you go down the group, the metallic character increases. Now, metallic character increases means metals are having a basic oxides, and so we are seeing an increase in the basic character of this higher, or you would say heavier elements oxides. Okay, I hope this part is clear to you. Next, moving on to boron. So now we will study specifically about boron, and this is very important for your examinations as well. We will try to discuss its compound in the next class. Today we will only see the preparation of borons. So some of the important mineral of boron are borax, which is Na2B4O7.10H2O. Then we have orthoboric acid, which is H3BO3, and then kernite, which is Na2B4O7.4H2O. As I said earlier, we will try to discuss mainly about the preparation of boron. First method is your electrolysis of the fused mixture containing boric anhydride, magnesium oxide and the magnesium fluoride at 1100 degrees Celsius. So if you do an electrolysis, first of all, the magnesium oxide will be broken into magnesium and oxygen. Then this magnesium which is formed here, it can be reacted or electrolyzed with the B2O3 to form the boron. Okay, so this is your first method that we are using. What we are doing? We are doing an electrolysis of the fused mixture of your boric anhydride, magnesium oxide and magnesium fluoride. So first of all, magnesium oxide and fluoride will react. Magnesium oxide will undergo electrolysis to form magnesium, and then B2O3 will react with this released Mg to form the pure boron. After that, the next method is the use of crystalline boron, is the use of B2O3 with aluminium powder. So your crystalline boron is obtained if you are reducing your B2O3 with aluminium powder. Now how it is reducing? It's very simple. It is basically accepting electron from the boron, or you can say it is accepting oxygen from the boron, and you know it is very well that removal of oxygen is simply reduction. So we are taking B2O3 to 2 boron. Here also we are forming boron. This is the second method. Next, if I talk about the amorphous boron, which are of low purity, and it is also known as Moissan boron. This thing is black in color. So first one is your crystalline boron, which is obtained by the reduction of B2O3 with aluminium powder, and second one is amorphous boron. Okay. Next, moving on to physical properties of boron. So boron, as we know, exists in two allotropic form, crystalline form and the amorphous form. Of one of these, we have seen the preparation of crystalline, and we have also noticed the physical appearance of the amorphous. So your crystalline boron is chemically inert in nature, whereas your amorphous boron is chemically active in nature, and it is a bad conductor of heat and electricity. This boron you are seeing, it is a bad conductor of heat and electricity. Moving on to the chemical properties. First of all, about the amorphous boron. So if you are heating it with air at 700 degrees Celsius, then they can form mixtures of oxides and nitrides. It's a very simple reaction. So B is reacting with O2. So 4B plus 3O2 is giving us 2B2O3. This is the possible oxide. They are exchanging their valency only. Then next we have 2B plus N2 giving us Bn. Here also they are exchanging their valency, and 3 and 3 is getting cancelled out. Okay. Next, if you treat your boron with oxidizing agents such as H2SO4 and HNO3, then it can be oxidized to form H3BO3. Okay. Similarly, if it is dissolved in fused alkali, and then it liberates hydrogen. Okay, so boron plus 6 NaOH gives us Na3BO3 plus 3H2. So these are the chemical properties of your boron. First, we have reacted with this oxygen to form the corresponding oxide, then with nitrogen to form the boron nitride, and then with the oxidizing agent to form the H3BO3, and lastly, it is dissolved in the alkali to form the Na3BO3. Okay, moving on further with this chemical properties. So, it reacts with strong electropositive metals. For example, it reacts with the magnesium to form Mg3B2. Again, it's a simple reaction. Here we are only exchanging the valency of magnesium and boron. So this is the reaction expected, 3Mg plus B2 giving us Mg3B2. Here if you see the reactions carefully, they are not that much complicated. We are simply reacting it with the stable form and then we are exchanging their valency to get our final product. Now next, this thing that you are seeing is a powerful reducing agent. Okay. So next reaction is 3CO2 plus 4B giving us 2B2O3 and 3C. Again we can have more examples of silicon oxides reacting with boron to form B2O3 and silicon. Okay, moving on to the uses. So it is used in the control rods, in the atomic reactors. Basically, they are capable of absorbing the extra neutrons which are released during the radiation reactions. Okay, especially during the nuclear fission. Therefore, they are used in the atomic reactors to absorb radiation of atomic or you can say nuclear reactions, and they act as oxidizer. Last, we have ore of aluminium. So we have seen a lot about the reactions of boron, preparations of some oxides and halides and all, and uses of boron. Now we will see the ores of aluminium. We know it very well. A very important ore of aluminium is bauxite, which is represented as AlOx OH whole 3 minus 2x. Here, x is having a greater value than 0 and lesser value than 1. Then the second important ore from which your alumini can be obtained is your Al2OH whole 4 Si2O5, which is known as kaolinite. What about the preparation? So your bauxite contains SiO2, iron oxides and titanium oxides as impurities. And if you want to purify it, you have to leach out the bauxite ore with the concentrated sodium hydroxide solution. Then aluminium can also be obtained by the hydrolysis of Al2O3, which is mixed with Na3AlF6 or Ca2F2. This is also known as Hall-Herlot process. If you just combine these reactions, you will get it as 2L2O3 gives us 4Al plus 3O2. Got it? Lastly, we have physical properties. So this aluminium, it's bluish white lustrous metal, and with time it loses its luster due to the formation of your aluminium oxide, which acts as a protective layer for the existing aluminium. Next, since it is a good metal, it can be light. Further, it is malleable, ductile, means it can be drawn into wire or beaten into sheets, and also they are good conductors of heat and electricity. Got it? So this was all for the theory part. Now we'll do questions. Okay, so I've tried to put up a mixture of questions and theories, because in your inorganic or especially your P block, you will see questions directly from the theoretical path rather than solving it. So I will try to cover the whole part of this group P block element from the theory as well as the question. Okay, so you will of course see question from silicons which are being not taught in the theory part. I will try to give rationals for it, important rationals and related facts from this silicons. Okay, so just wait for a while. I will just open the P So here is your first question. Question says that boric acid is called acid. Why is the reason behind it? Means you have to define the chemical behavior of the boric acid molecule uh, to explain its acidic nature. First one, it contains a replaceable H plus ion. It's very simple. You have to say that whether it is containing H plus ion or not. As simple as that. Second thing, it can give up a proton. That same thing is being repeated in a different way. Third one, it accepts OH minus from the water releasing proton. And lastly, it combines with proton from water molecule. Okay. So you cannot confuse this thing, this accepts of OH minus from water releasing proton. So this giving proton and this is different. So basically, it is saying that if you react your boric acid with water, then it will react with the OH minus of the water and release the H plus part of the water. You know it very well. Water has two parts, OH minus and H plus. So it basically reacts with OH minus and releases H plus. Fourth is it combines with the proton to form water molecule. Now you have to tell that for with proton from water molecule. You have to tell that which one is the correct one. So it's a very easy one, I guess, because from the options itself, the correct answer would be clear. Okay. If you consider the last point, it combines with proton. So if it will combine with proton, then the OH minus part will be left into the solution and that will create a basic solution, not a acidic one. Okay, so I hope this hint is appreciable for solving this question. So what will be the answer for this question? Anyone? So what will be the answer for this question? Why your boric acid is known as an acid and not a base, and what is the particular reaction it shows while acting as an acid? Anyone, can you tell me what is the correct answer? Just post it in the comment section. Okay, I will wait for one more minute. Just try to figure it out that when can an acid act as an acid? As simple as that. You can just remove options also. Their remove options are very much wrong at the first sight only. If you consider the general formula for boric acid, you will find that your correct answer is very easy to get. Can you tell me what is the correct answer? Just post it in the comment section. Okay, so I'm seeing answer as option number C. Anyone else? What is the correct answer? So 8 people are watching here. So can you anyone tell me what is the correct answer? Remember, it has no proton in it. Okay, so this is also a hint for you. The boric acid has no proton in its formula. Okay, so let's see if this answer is correct or not. Option number C. So the correct option will be option number C. Very good. That it accepts OH minus from water releasing proton. Basically, if you talk about the boron atom in the boric acid, it has a very small size and presence of 6 electrons inside it. Okay. Now, your boric acid has a lack of valency. Got it? means its octet is not complete. Therefore, it will accept a pair of electron and act as a base. But how it will accept? That electron can come from anything, right? So it can come from your NH3 or any other base. But here we are telling that we are considering it in water. So in water we have OH minus and H plus, and your OH minus is present in a very small amount, which is 10 to the power minus 7 for neutral water at 25 degrees Celsius. So your boric acid will accept the electron from this OH minus, this negative sign will donate the electron, and hence the positive part of your water will be released into the solution, creating an acidic solution. This is the way your boric acid acts as an acid. Okay, so rather than giving H plus ion, because it has no H plus present in its formula at the first site. Okay, so it acts as an acid by accepting the OH minus from the water. Next, you have to tell that upon heating of an aqueous solution of aluminium chloride to dryness, what will be the product? So what are we doing? We are trying to react your aluminium chloride, which is AlCl3, with the water in the presence of heat. Okay. So remember, your water is amphoteric in nature. It can act as an acid and base both. And second thing, your AlCl3 is a Lewis acid. So it can accept the OH minus. So this hint I think is enough for you. And what does heating does to any molecule? It removes the molecule of water. Okay, it's very simple to understand that point. Just try to figure it out. So four options are given here: AlOH Cl2, second one Al2O3, third one Al2Cl6, and fourth one AlCl3. So your time is now started. Just vote it here, or you can write it in the comment section as well if you want. So what you have to think? You have to think that since it is AlCl3, therefore it will act as a Lewis acid because it has a lack of octet. Then how it can act as an acid? By accepting the electron, and that electron will come from the OH minus part of the water. Okay, so first it will react with the OH minus. Then after you have to heat it, and upon heating the water removal will take place. Anyone else? So we are seeing an answer of B. So if you are willing to give the answer, please give it here in the comment section, or else you can vote it in the poll section as well. Okay. So let me just say the answer. So the correct answer would be B, Al2O3. So how can we do it? As I said earlier, first it will be hydrolysis of your AlCl3. So what will happen? The 3 Cls will be removed by the OH. So as soon as you introduce this AlCl3 into water, it will act as a Lewis acid and accept the electron from the OH. This OH will donate electron and it will remove the Cl one by one, creating AlOH whole thrice. Now next is heating. So heating can result in different compound. But the problem is that if you remove water from one molecule only, from suppose I remove it from AlOH3 only, from one molecule of AlOH3, what it will result in? It will result in AlH2. Okay, so that is the possible thing. AlH2, AlHO2. So this will be the possible compound that you can get. But believe me, there is no such compound, and you have not seen such compound also. Therefore, we will try to remove it from two molecules of AlOH thrice. And if you do so, it will result in the formation of Al2O3 and 3H2. You can clearly see that upon heating, what will happen? Molecules of water will evaporate, and here 3 molecules of water are evaporated from 2 molecules of AlOH whole thrice to form the Al2O3, which is option number B. Okay. Next question. So, boron cannot form which one of the following anions? First option is BF63 minus, BH4 minus, BOH4 minus, and BO2 minus. So, here again the question is coming from the anomalous behavior of the first member of your P block element. Okay, so you know it very well that your second period elements are capable of showing a maximum covalency, especially for the 13 group as 3. And the reason is what? I can show it is up to 4 also. And the reason is what? Is the unavailability of the d orbital or the d subshell. Got it? Because if it is belonging to second period means it can have a maximum of second shell in the given atom. So it can have 2s and 2p and not 2d. Got it? Therefore, its covalency cannot be exceeded to a greatness of 5 or 4 or 5 or 6. So now you can, I hope, easily tell me the answer. Can you tell me what will the correct answer then? So we have 4 options: BF63 minus, BH4 minus, BOH4 minus and BO2 minus. Just try to calculate the know the covalency and see whether the given covalency is possible or not. Is there any vacant orbital for that existing covalency or not, and you will easily get your answer. If you get an answer, just please comment it here in the comment section. Moving on further, what will be the correct answer? It will be A, which is BF63 minus. Now, what is the reason? If you look upon the excited state of your boron also, you can clearly see that it can accommodate maximum of 4 part. So 1 here, 2 here, 3 and 4 here along with a negative sign. Okay, so it can form BH4 minus or it can form BOOH4 minus, but it cannot accommodate 6 fluorine atoms. There are no vacant orbital to accept except the the electron pairs of fluorine. Got it? Therefore, it can have a maximum covalency of 4. Hence, due to the absence of d orbital and maximum covalency of 4, BF63 minus is not formed. Okay, whereas BH4 minus, BOOH4 minus and BO2 minus are possible. Moving on to the next question. You have to mark the oxide which are amphoteric in nature. So we have already discussed about this and we have seen that what are the possible P block elements that can form amphoteric oxides. Options are carbon dioxide, silicon oxides, then we have tin oxides and calcium oxide. What will be the correct answer? So I told you a mnemonic also to remember the names of amphoteric oxides. So just think about that, or if you know it, you can just write it here from our theory discussion also. Anyone? Can you tell me the correct answer? So what are the oxides that are amphoteric in nature? So I'm giving you one more hint here. Metalloids forms amphoteric oxide because they fall in between the metals and non-metals. You know, metals are forming basic oxide, whereas non-metal form acidic or neutral oxide, whereas the metalloids are falling in the between those, so they can act both as an acid and base. Now you have to choose that which element is forming an oxide is closer to metalloids or are metalloids. Anyone, can you tell me what will be the correct answer for this? So moving on to the correct answer. So I told you about some elements that can form amphoteric oxide. So those were tin, gallium, then we have aluminium. Okay, so these are some amphoteric oxides and we have discussed about the names also. So from that list only we have one of the compound which is an oxide of tin. Therefore, SnO2 is the only present amphoteric oxide and it can act as a both acid and base. Yes, so it would be option number C. What is the reaction which can be shown here? It is SnO2 plus 2H2SO4 giving us SnS4 whole twice and 2H2O. Similarly, if you try to react it with the base, it will react with the base to form Na2SnO3 plus H2O. So in both cases, it is forming salts along with the water. Next question. Graphite is a soft, solid lubricant, extremely difficult to melt. The reason for this anomalous behavior is that first one, graphite is an allotropic form of diamond. Second, it has molecules of variable molecular masses like polymer. Third one, graphite has carbon atoms arranged in a large plate of rings of strongly bonded carbon atoms with weak interplate bonds. Lastly, it is a non-crystalline substance. So here third point is something which is important to understand. If you talk about the graphite structure, so there we have hexagonals formed by the carbon. Okay, there is a sheet like thing and there are multiple sheets which is present in the graphite. Between two sheets we have van der Waal, weak van der Waal force present in between. Okay, and as a result of this weak van der Waal force they can slip over each other, and that is the reason it acts as a good lubricant. Now remember, it is an allotropic form of your carbon. Got it? Now if I try to just eliminate options, you can clearly say that the first option is absolutely wrong because diamond is not an element. Allotropes are possible for elements, not for a given species. So the allotropes of carbon is diamond, your fullerene and your graphite. So diamond itself is an allotrope of carbon. Next, it has molecule of variable molecular mass. Okay, this is also not possible. Only carbon is present there and they are not of variable molecular mass. Got it? Third one is correct. As I said earlier, they are formed of sheets and those sheets are held together by weak van der Waal force. So they can slip over each other and hence they can act as a lubricant. So this is the reason also your graphite is soft as well as a good lubricant. Then after, it is a non-crystalline substance. This is also not correct. Moving on to the correct answer, which is option number C, which is it has carbon atoms arranged in large plates of ring of strongly bonded carbon atom with weak interplate force. So they form hexagonal layers and between those hexagonal sheets we have van der Waal interaction present in between. Next one, carborundum is obtained when silica is heated at high temperature with. So this is a direct theoretical question. I can't give rationale for this. You must know what is carborundum is, and the options are carbon, carbon monoxide, carbon dioxide and calcium carbonate. Okay, so you have to tell that how you can get your carborundum if you are reacting your silica with a particular element. So you have to decide that element or that compound. Anyone who knows the answer can quickly comment it here. It's a direct theoretical question. If you know it, So the correct option would be option number A. Whenever you heat your carbon with your silica, then that results in carborundum whose formula is SiC. So this is a direct theoretical question where SiO2 is reacting with three molecules of carbon at high temperature, which is 2300 Kelvin, and it gives us carborundum whose formula is SiC. Apart from this, we are also getting carbon monoxides 2 mole. Next question. Here, among the given silanes, you have to say that which upon hydrolysis form cross linkage. Okay. Now, here one very important thing, the bond between carbon and your silicon is very strong as compared to the bond between silicon and chlorine. So if you react your given silane with water or do its hydrolysis in other terms, then your water molecules will quickly attack the bond between silicon and your chlorine. Okay, so which part will attack? The OH minus part will attack from the water, and it will try to replace the chlorine atom from the given silane and form the hydroxide. Next, you have to see that which one is capable of forming the good network of cross linkage. So more is the counting of this hydroxide, more is the possibility of seeing the hydrogen bonding. Okay, and more good will be your cross linkage. Now that is the simple logic you have to apply. If you do that, you will clearly see that out of the four given options, our SiCl3 had the maximum number of chlorine which are replaceable from the by the OH. So we can write in the solution that your RSiCl3 will react with water, and as a result of this the OH minus will attack and remove the 3 chlorine atoms, creating RSiOH whole thrice. Then it will polymerize due to cross linkage between the oxygen and all, and hence it will form this polymer of nth order. Next question. So this is your answer. RSiCl3 gives cross-linked silicon polymer on hydrolysis. Next one is name of the structure of silicates in which 3 oxygen atoms of SiO4 whole 4 minus are shared is. Now this is something which requires trick to remember. There are various type of silicates which are possible. I will try to give you a trick for this or a mnemonic device for this. Just note it down. First of all, in the first column you write old people can drive safe car. So write in every row you write one word. Old people can drive safe trucks. Then for old you have orthosilicate. Then for people you have pyrosilicate. Next, can stand for chain or cyclic. Then drive stand for amphibole. Then safe stand for sheet silicate, and trucks stand for tecto. So these are the 6 silicates which are possible: orthosilicate, pyrosilicate, chain or cyclic silicate, then amphibole silicate, then we have sheet silicate, and lastly tectosilicate. So this is your second column. Next, you write the number of electrons which are shared for each of this. First one 0, second 1, third 2, fourth 2.5, then in third we have 3, and last we have 4. Lastly, we have the structure. Okay, now each of them have different type of structure. What are the structure? So for orthosilicate, if I talk, then orthosilicate is something which is having a discrete structure. Discrete means there is no linkage between the two. Next we have pyro. Okay, next we have the pyrosilicate. So for pyro, what is the structure? Pyro, in pyro we have 2 units joined together. Okay, in pyro we have two units joined together, means there is a dimeric form. Third one is your linear one. So in linear part there is a linear chain which is present, which has nth number of order. Now here we have no definite thing. Third one is your amphibole. Okay, amphibole has no definite shape, so we'll not talk about this. Questions do not come from here. Then the fifth one is your what? Fifth one is your sheet silicate. So sheet silicate, since it is a sheet, it will be planar or it will be a 2D structure. And lastly, we have tectosilicate, which is 3-dimensional. So again, I'm repeating it. For orthosilicate, there are individual units which are present. Then for pyrosilicates, we have a group of 2 and 2. In linear, we have a straight chain. You leave it for the double chain or the amphiboles. We don't talk about this. Then we have sheet silicate. Of course, if it is sheet, if it is 2-dimensional in nature. And third is tectosilicate, which is 3-dimensional. Okay. Now here pyrosilicate, it is falling in the second. Here the oxygen shared is 2. Okay. Then in sheet silicate it is 3. Then about linear chain, what is the one? For linear chain it will be 2. And lastly for 3-dimensional it is 3. Okay. For 3-dimensional silicate it is 3. So what will be the correct? Sorry, 3-dimensional will be 4, because it comes under the tectosilicate. The question says that you have to tell which one shares 3 oxygens. So directly you can say that 3 oxygens are shared by the sheet silicate. Therefore, the correct answer would be option number B. Okay. So from the X-ray diffraction technique, the structure of silicate is find out, and it is said that it shares 3 oxygens. Now, what about the general formula? So the general formula is S2O5 and 2N minus. Okay. Is it clear to you? And 1 unit is SiO4 4 minus. Got it? Is it clear to you? So this was all for today's class. So here is a question for you. You can just try to solve it. In next session, we will start the second part of this P block element. Thank you for joining the session. I hope you enjoyed it.
Hello everyone. So in today's class, we will discuss area bounded by curves. Okay. Okay. So according to last 8-year data, the chapter weightage for this chapter is 3.83%. And according to previous years, one question have been asked each year. Okay. And year-wise analysis. So in the year 2024, one question came from the topic area bounded between two curves based on the formula area is equal to integral from b to a fx minus gx dx of average level. Okay. So each year one question came from this topic based on area bounded between two curves and area of region bounded by a curve and between two ordinate. Okay. So in today's lecture, we will first learn about what is curve area. Then we will learn how to evaluate the area between a curve and line. And finally, we will learn how to evaluate the area between two curves. Okay. So, let's suppose we have a function and that is a continuous curve. So, when we talk about a continuous curve, meaning a line that runs smoothly without any break, and that curve is enclosed within certain condition such as below the x-axis or between a fixed range, then the space occupied by this continuous curve below the curve and that area is called curve area. Okay. So if you have any continuous curve which is bounded by certain condition, then the area under the curve is called curve area. Okay. So this shaded area is the curve area for the curve for this curve. Okay. So to find the area under the curve, this is the application of integral. As in the last class, we discuss about definite integral. So the definite integral is nothing but area of the function between the upper limit and lower limit. That's the reason bounded by the curve, its ordinate. If you calculate the definite integral from a to b fx dx, then this gives the area of the region bounded by the curve fx, y is equal to fx, and the ordinate x equal to a, x equal to b, and x axis. Okay. So this is the application of definite integral. So let's suppose we have a curve y is equal to fx and we want to calculate this shaded region, the area under the curve, and this is the region bounded by the ordinate x is equal to alpha and x is equal to beta. So function fx is defined on the closed interval alpha to beta, and this is the region that is bounded by the curve, the line x equal to alpha, x equal to beta, and the x-axis. So this area is given by the definite integral from alpha to beta y dx or alpha to beta fx dx. Okay. So how we calculate? We just divide this region into different number of rectangles. Okay. Very thin strip. We divide into very thin strips, and when there is a strip with width dx and length y. So what is the area of this strip, this rectangle strip? The area is given by y into dx. And when we integrate this area over the range x equal to alpha to beta. So this gives the area of the whole region. Okay, so this area is given by integration alpha to beta y dx, where y dx is area of this thin strip, and when we integrate from alpha to beta, we get the entire area of this bounded region. Okay. Now, if there is a curve y is equal to fx and which lies below the x-axis, meaning the curve value are negative, and this curve is bounded by the line x equal to alpha and x equal to beta. Okay, then when we find the area of that region using integration, that is alpha to beta fx dx, then this value is negative. Okay, but area is never negative, so to take area as positive, we take modulus of definite integral from alpha to beta y dx, or definite integral from alpha to beta fx dx. So to calculate area of a curve under the curve which lie below the x-axis, we take the modulus of area from alpha to beta y dx. Okay. Now, if we have a curve x is equal to fy, which is defined in vertical direction. So now the bounded region is bounded by the line y is equal to c, y is equal to d, and the curve x is equal to fy. So we need to calculate this shaded part, this shaded region. Okay. So for this, we take a thin strip of width dy and length x. And what is the area of this thin strip? Is x dy. That is, consider it as a rectangle. So area of this rectangle is x into dy. And when we integrate from c to d of this area of this thin strip, we get the area of this entire region, entire bounded region, and that is equal to integral, definite integral from c to d fy dy, or c to d x dy. Fy is the x equal to fy is the length of this thin strip, which changes. Okay, so we integrate with respect to y, and y changes from c to d, so that we get definite integral from c to d fy dy, and as x is equal to fy, so we get c to d x dy. Okay, and if the position of the curve under consideration is on the left side of y-axis, then area is given by, we just take mod of integral c to d fy dy. Okay, because the if is on the left side of y-axis, meaning the value of x are negative, and then the result of the integration will also be negative. But as we discussed earlier, area is never negative, and that's why we take the modulus of definite integral from c to d fy dy. Now we'll discuss area between a curve and lines. So if the curve crosses the x-axis multiple times, meaning sometime the curve is above the x-axis and sometime below, and is bounded by the line x is equal to alpha to x is equal to beta, then we cannot find its area directly by integration, because some portion become negative. Okay, so if there is a function y is equal to fx, so see this figure. So this figure, some portion lies above the x-axis and some portion lies below the x-axis. So according to the last slides, the area which lies below the x-axis, we take the mod of definite integral from, like for this alpha 1 to alpha 2 fx dx, we take the mod value, because when we find this integration we get a negative value, and as area is never negative, so we must need to take the mod sign for the definite integral from alpha 1 to alpha 2 fx dx. So we cannot find the area by directly integrating from alpha to beta. Okay, so we must need to break our integration according to the area where the curve lies below the x-axis or where the curve lies above the x-axis. Okay, so from this figure, the curve y is equal to fx is lies above the x-axis from alpha to alpha 1 and alpha 2 to beta, and it lies below the x-axis from alpha 1 to alpha 2. So to calculate its area, what we do, we find the definite integral from alpha to alpha 1 fx dx, then add the area from alpha 1 to alpha 2 fx dx and take the mod sign plus definite integral from alpha 2 to beta fx dx. Okay, so that's how we calculate area of under this curve when it crosses the x-axis multiple times. Clear? Now, now we'll talk about area between two curves. So let's suppose we have two curves and we will try to want to find the area between these two curves. Okay, so let's suppose we have two curves y is equal to fx and y is equal to gx. So the area between this curve, it is a shaded region according to this figure. Just see the figure, there is a one curve y is equal to gx and y is equal to fx, and we want to find this area, this shaded region, this shaded area. Okay, so from x equal to a to x equal to b. So if fx is less than equal to gx and the line x is equal to a and x equal to b and a is less than b, then this shaded region, this area is given by the definite integral from a to b gx minus fx dx. How we get this? So let's suppose there is no y is equal to fx another function, just we have one function y is equal to gx. So how we can calculate the area under the curve y is equal to gx from x equal to a to x equal to b? We just take the definite integral from a to b gx dx. Clear? And if we have only one function y is equal to fx and we want to calculate the area under the curve y is equal to fx, then this is given by definite integral from a to b fx dx. Okay, so now we have two area. To calculate this region, that is area between y is equal to gx and y is equal to fx, we just take the subtraction of area under y is equal to gx minus area under y is equal to fx, and that is equal to integral from a to b gx dx minus integral from a to b fx dx. And as limit are same, so we get definite integral from a to b gx minus fx dx. Clear? Second point, if fx is greater than equal to gx in the interval close interval a to c and fx is less than equal to gx in c to b, so we have a closed interval a to b, but in this interval in some portion fx is greater than gx, greater than equal to gx, and on another sub interval fx is less than equal to gx. So according to that, we split our definite integral to find the area under the between these two curve. Okay, so on the subinterval from a to c fx is greater than equal to gx, and from c to b fx is less than equal to gx. Okay, and where this c lies between this a and b, then the area is given by, we find the definite integral from a to c fx minus gx dx, upper curve minus lower curve, as fx is greater than equal to gx. plus C2b gx minus fx dx, because in the interval C2b fx is less than equal to gx, so we subtract the upper curve minus lower curve dx. Okay, the formula is def integral from upper lower limit to upper limit and then upper curve minus lower curve dx. That's how we can calculate area between two curves. Okay, first important thing is, if fx is greater than equal to gx, then area between these two curves fx and gx on the interval a to b is given by definite integral a to b gx minus fx dx, because gx is greater than equal to fx on the interval a to b. Okay, and if fx is greater than equal to gx, then fx minus gx dx. Okay, next, now area of the region shown in this following figure. There is a figure and we want to find the area between these curves. Okay, so we have two curves, y is equal to fx and y is equal to gx, and this region is bounded by the curve y is equal to fx, y is equal to gx, x-axis and the line x is equal to a and x is equal to b. So how we calculate this? So we split this area into two parts. The function y is equal to the curve y is equal to fx and y is equal to gx intersect at a point. So we split from the point of intersection. We draw a line x equal to c. At x equal to c, these two curves are intersecting. Okay. So at first, we find the area from a to c for a curve y is equal to fx, and then from c to b for a curve y is equal to gx. So we calculate area under a curve y is equal to fx from a to c, and after the point c, the curve is changes. The now curve become y is equal to gx. So now we calculate area under the curve y is equal to gx from c to b. So for the first part, area is equal to, now this area, the first part is bounded by the line x is equal to a and x equal to c, x axis and the curve y is equal to fx. Okay, so this area is given by definite integral from a to c fx dx, plus for second part it is given by from c to b gx dx. How we get this? So for the first part, we just take a thin strip, rectangle strip of width dx whose length is given by fx. So the area of that thin strip, that is a rectangle, is given by fx into dx, and when we integrate this area from a to c, we get the area of this first region. Okay, and for the second region, the length is given by gx, and when we take the thin rectangle of width dx, and when we integrate with respect to x from c to b, we get the area of the region below y is equal to gx and bounded by the y is equal to gx, x axis and x equal to c and x is equal to b. Okay, so now we'll discuss some important curves and area between two curves. Okay, so first curve is ellipse. Fxy is x square by a square plus y square by b square less than equal to 1. So x square plus x square by a square plus y square by b square is equal to 1 is an equation of ellipse. So we get an ellipse. Okay, then it is less than equal to 1. So we set it under the ellipse towards the origin, because when we substitute in place of x and a 0 0, so it becomes 0 less than 1. That is a correct statement. So we set it towards the origin for in this inequality x square by a square plus y square by b square less than equal to 1. Okay, Now, for the inequality x by a plus y by b greater than equal to 1. So at first, draw the line x is equal to a plus y by b is equal to 1. And then when we substitute origin, so we get 0 plus 0 greater than equal to 1. That means 0 is greater than equal to 1. It's a false statement. So origin is doesn't lie on the reason of x by a plus y by b greater than equal to 1. So we said it upwards the origin, not towards the origin. Okay, away from the origin. So we get this when we combine the both the reason of the inequality x square by a square plus y square by b square less than 1 equal to 1 and x by a plus y by b greater than equal to 1, we get this shaded region. So we want to find the area of this shaded region. Okay. So to find this area, at first we have to find the point of intersection of the line x by a plus y by b is equal to 1 and x square by a square plus y square by b square is equal to 1. So what are the point of intersection? First point a, that is a comma 0, and second is b, that is 0 comma b. Okay. Now we apply the formula of area between two curves and then we get the area between this is area is equal to AB into pi minus 2 by 4 square unit. Clear? How we calculate the area between two curves? If there is two curve y is equal to fx and y is equal to gy, y will equal gx, then we calculate the area by from the limit. Like there is a limit, upper limit and lower limit and upper limit. So we calculate differential from lower limit to upper limit. And if fx is greater than equal to gx, then upper curve, that is fx minus gx dx, which give you area between these two curve. Okay. Now, second, parabola y square is equal to 4ax and its lattice rectum x is equal to a. So here is a parabola that is given y square is equal to 4x, which is open to the right side. Okay. And what is lattice rectum? So the lattice rectum of the parabola is x is equal to a. That is a vertical line that passes through it, the focus of the parabola. Okay. So this is the shaded region, which region bounded by the curve y square is equal to 4ax and the lattice rectum x is equal to a. So we have to calculate the shaded region. So to calculate the shaded region, we just calculate the area of the first quadrant and then multiply it with 2 to get the area of this entire region. Why? Because due to the symmetry, the area above the x-axis and area below the x-axis is same. So you only need to calculate the area which lies on the first quadrant. Okay. So first find the point of intersection. So point of intersection is a is equal to a comma 2a and b is equal to a comma minus 2. These are the point of intersection where the y square is equal to 4x, the parabola, and the line x is equal to a intersect. Okay. So just apply the formula of how we calculate area by using a definite integral. We get area is equal to 8 by 3 a square square unit. Okay. How we calculate this? So first we calculate the area for the first quadrant. So we just take a thin strip of width dx and whose length is given by the function y square is equal to 4x, that is y is equal to root under 4ax, that is 2 root under a root x. So area of the rectangle is 2 into root a into root x into dx. And when we integrate this from 0 to a, so integration from 0 to a of 2 into root a into root x dx gives the area of the region on the first quadrant. And when we multiply it with 2, we get the area of this entire shaded region, and that is equal to 8 by 3 a square square unit. Clear? Now, third, the first curve is y square is equal to 4ax, which is a parabola. which open to the right side. Second curve is y is equal to mod mx, meaning a V-shaped line. Okay. So see the figure. There is a curve. There is a first curve y square is equal to 4x, the parabola which open to the right side, and the curve y is equal to mod mx is the V-shaped curve. Okay. So we need to find this shaded region, this area between these two curve. Okay. So for this, first find the point of intersection of for both this curve. So this curve intersect at origin 0 comma 0 and at a, and points of we can find the coordinates of a by solving this two equation, and that is 4a by m square, 4a by m. So x coordinate is 4a by m square and y coordinate is 4a by m. So how we can calculate this area? There is a two curve. So we just integrate from 0 to x coordinate, that is 4a by m square. So limit of the different integral is from 0 to 4a by m square, and apply the formula of definite integral to calculate area between two curves. So the formula is upper curve minus lower curve dx give you the area of this shaded region, and that is equal to 8a square by 3m cube square unit. Okay. Now next curve is fxy, that is x square is equal to 4ay, and second curve is y square is equal to 4bx. So here are two curves and both are parabola. First curve, that is x square is equal to 4ay, an upward opening parabola, and second curve, that is y square is equal to 4bx, is a rightward opening parabola. And both curves start from origin. So the vertex for both curve is origin 0 comma 0, and point of intersection for both curve is your a, that is 4 into a the power 2 by 3 b the power 1 by 3 comma 4 into a the power 1 by 3 b the power 2 by 3. Okay. So we use the formula for formula of definite integral to calculate area between these two curve, and which is 16 by 3 ab square unit. Okay. Next, these are the particular cases of two curves, area between these two curves. So fifth number, first curve is y square is equal to 4a into x plus a. Okay. And second curve is y square is equal to 4b b minus x. So this both curve represent parabola. First, y square is equal to 4a x plus a is left shifted right opening parabola. And the second curve, y square is equal to 4b b minus x is right shifted left opening parabola. Both curve from an enclosed region between points a, b minus a, 2 root under ab, and b, that point is b minus a comma minus 2 root under ab. And the area of this bounded region is given by area is equal to 8 by 3 root under ab into a plus b square unit. Okay. Now again, first curve is x square by b square plus y square by a square is equal to 1 by a square b square. And another is x square by a square plus y square by b square is equal to 1 by a square b square. Both are the equation of ellipse. One is vertical stretch and one is horizontal stretch. So we need to find the area PQRS. So at first find the point of intersection. So point of intersection is x is equal to y is equal to plus minus 1 by root under a square plus b square. And then we apply the formula of area between two curves, and we calculate this area PQRS. So by using the symmetry, So due to symmetry, if we calculate the area OLQM and multiply it by 4, then we get area PQRS. So at first, by using the formula, calculate area of MOLQM and then multiply with 4 to the get the area PQRS, and that is we get 4 by AB tan inverse A by B square unit. Okay, so these are the some important two curves and the area between these two curve. Okay, next is what is curve? If alpha beta is greater than 0 and alpha is greater than b, the area between the hyperbola xy is equal to p square. So this is the hyperbola, which is a rectangular hyperbola, and we need to find its area which is above the x-axis and between two vertical line, x is equal to alpha and x is equal to beta. Okay, where alpha beta is greater than 0 and alpha is greater than beta. Okay, so see the figure. This is a shaded region. We want to find this area which lies from x is equal to beta to x equal to alpha, and the rectangular hyperbola xy is equal to p square. Okay, so we apply the formula of definite integral. So the area of this region is p square log alpha by beta. Okay, so let's summarize. So if we have any continuous curve which is bounded at certain condition, then the space occupied by this continuous curve is called curve area. And this area between a curve and line is calculated by the definite integral. So if there is a curve y is equal to fx, which is defined on interval alpha to beta, and the region is bounded by this curve y is equal to fx, x-axis, and the line x equal to alpha and x equal to beta, then this area is given by definite integral from alpha to beta y dx or definite integral from alpha to beta fx dx. Okay, and if your region, if the curve lies below the x-axis, then the value of definite integral is negative, so we take the mod value to find the area, because area is always positive. So this area is given by mod definite integral from alpha to beta y dx. Okay, and area between curve, area of a region bounded by the curve x is equal to fy. Now this region is bounded by the curve x equal to fy and the line y is equal to c and y is equal to d. So this is given by definite integral from c to d fy dy or definite integral from c to d x dy. And if the curve crosses the x-axis number of times, then this area is given by, if you want to calculate if the curve is y is equal to fx and the region is bounded by the y is equal to fx and the line x equal to x-axis and the line x equal to alpha and y is equal to beta, then this area is given by according to the which region is lies below the x-axis and which region lie above the x-axis. So that region which lies below the x-axis, we take the mod of definite integral. So we get alpha to alpha 1 fx dx, this region lies above the x-axis, and from alpha to alpha 2 the region lies below the x-axis, we take the mod value. So mod alpha to alpha 2 fx dx plus integral from alpha 2 to beta fx dx. Okay, and if there is there is two curve and we want to find the area between these curve. So if the first curve is y is equal to fx and second curve is y is equal to gx, and if fx is less than equal to gx and the region is bounded by the line x equal to a and x equal to b, where a is less than equal to b, then the area between these two curve is given by from a to b gx minus fx dx. Okay, very important formula. Here gx is upper curve and fx is lower curve, as fx is less than equal to gx on the interval a to b. So we calculate the area as definite integral from a to b gx minus fx dx. Okay, and if on the interval a to b in the sum portion a to z, fx is greater than equal to gx, and on the interval c to b, fx is less than equal to gx, then the area is given by definite integral from a to c fx minus gx, because on this subinterval fx is greater than equal to gx, fx is your upper curve, so you get fx minus gx dx. And for the subinterval c to b gx minus fx, because here gx is your upper curve and fx is a lower curve. Okay, so in each interval the integration of upper curve minus lower curve must be taken. Okay, just wait for a moment. Okay, so now we'll practice some question based on area bounded by curves. So first question, let f defined from -1 to 2 to 0 to infinity be a continuous function such that fx is equal to f1 minus x for all x belongs to close interval -1 to 2, and let r1 is equal to definite integral from -1 to 2 x fx dx, and r2 be the area of region bounded by y is equal to fx, x is equal to -1, x equal to 2, and the x-axis. Then, which option are correct? Which option is correct? A, r1 is equal to 2r2, r1 is equal to 3r2, 2r1 is equal to r2, and 3r1 is equal to r2. So in this question, we have to find the relation between the area r1 and r2. r1 is the definite integral from -1 to 2 x fx dx, whereas function fx is defined from -1 to 2 to 0 to infinity. So domain of this function is -1 to 2. And there is one another property. First thing is this function is continuous function, and second thing is fx is equal to f1 minus x for all x belongs to -1 to 2. Okay. Now what is r2? r2 is the area, the region bounded by the curve y is equal to fx, and the line x is equal to -1 and x is equal to 2, and the axis. Okay, so we can calculate this r2, this area, by using the definite integral, because this is a bounded region, and we can find out this area by using a definite integral. Okay, so try this question. as a hint, we use a very important properties of definite integral to solve this problem. And that property is the definite integral from a to b fx dx is equal to definite integral from a to b f a plus b minus x dx. Okay, so we use that property to solve this problem. Okay, so try. R2 is given by the definite integral from lower limit x is equal to minus 1 to x is equal to 2 fx dx. Okay, just try. Or we can relate the definite integral from minus 1 to 2 x fx dx to definite integral from fx dx from minus 1 to 2 fx dx. And as a hint, we use a property from definite integral, and the property is definite integral from a to b fx dx is equal to definite integral from a to b f a plus b minus x dx. Okay, so let's solve together. Correct answer is option C, that is 2r1 is equal to r2. Okay, so given r1 is equal to definite integral from minus 1 to 2 x fx dx, and r2 is the area of the region bounded by the curve y is equal to fx, the ordinate x is equal to minus 1, x is equal to 2, and the x-axis. And this is given by the definite integral, that is r2 is equal to definite integral from minus 1 to 2 fx dx. Okay, this is the formula. Now we have to relate r1 and r2, and one also important thing is that fx is equal to f1 minus x. So now r1 is equal to minus 1 to 2 x fx dx. So here we apply the property of definite integral, that is definite integral from a to b fx dx is equal to definite integral from a to b f a plus b minus x dx. So a is minus 1, b is 2. So a plus b is 2 minus 1, that is 1. So minus 1 to 2 definite integral 1 minus x, a plus b minus x into f 1 minus x dx. Okay, and we know that f at 1 minus x is equal to fx. So we substitute this value, we get minus 1 to 2 definite integral 1 minus x fx dx. Now simply distribute the integral, we get minus 1 to 2 fx dx minus minus 1 to 2 integral x fx dx. Okay, so the first part, that is minus definite integral from minus 1 to 2 fx dx, is area of the region bounded by the curve y is equal to fx, the line x is equal to minus 1 and line x is equal to 2, and that is represented by r2. And the second term is your r1. So we get r1 is equal to r2 minus r1, that is r2 is equal to 2 r1. So option C is correct. Clear? Any doubt? Next question. Let A1 be the area of the parabola y square is equal to 4ax lying between the vertex and the lattice rectum, and A2 be the area between the lattice rectum and the double ordinate x is equal to 2a. Then A1 by A2 is, options are 2 root 2 minus 1 by 7, option B, 2 root 2 plus 1 by 7, option C, 2 root 2 plus 1, and option D, 2 root 2 minus 1. Okay. So in this question, we have to find the ratio of the area A1 and A2. And what is A1? So A1 is the area which is bounded by the parabola y square is equal to 4x, and the area is lying between the vertex and the lattice rectum. Okay, so what is the equation of lattice rectum? That is x is equal to a. So we have to find the area between the vertex and the lattice rectum, that is equal to a line, and the curve, the parabola y square is equal to 4ax, that is your area A1. And when we calculate A2, so A2 is the area between the lattice rectum and the double ordinate. So the line x is equal to a, the line x is equal to 2a, and the curve is same curve, that parabola y square is equal to 4x. So here function is y square is equal to 4x, the curve is y is equal to 4x, ordinate is x is equal to a and x is equal to 2a, and the x-axis. So this is your area A2. So by using the formula for of definite integral, we calculate the area A1 and then A2, and then we take the ratio. Then which option is correct? Either A, B, C, and D. Okay, so try. At first, according to the question, try to draw the figure of the parabola y square is equal to 4ax and the lattice rectum x is equal to a and the double ordinate x is equal to 2a, and stated the reason, which reason is a1 and which reason is a2, and then find a1 and a2 by using definite integral. Okay, to calculate the area we must need to recognize what is the limit, upper limit and lower limit. And also how we take the strip, either it is a strip of width dx and length y, so that is area is given by y dx, and then we integrate on the range of x, that is on the limit of x, that is lower limit to upper limit y dx. Okay, okay, so let's solve. Correct answer is option B, that is 2 root 2 plus 1 by 7. So this is the figure. How we draw? First we draw the parabola, that is y square is equal to 4x. Okay, this is the parabola y square is equal to 4x. The vertex is 0 comma 0 and the focus is a comma 0. So the lattice rectum, that is a line x is equal to a, passes through the focus and perpendicular to the line of symmetry. So this is perpendicular to x-axis. So this is your lattice rectum. So a1 is the area, first reason part, first stated reason, from the vertex to the line x is equal to a, and the curve y square is equal to 4x, and a to be the area between the lattice rectum x is equal to a, double ordinate x is equal to 2a, and the curve, that parabola y square is equal to 4x. So at first we need to find a1 and then a2 and then take the ratio to find a1 by a2. Okay. So how we can calculate a1? So from this figure, one thing is clear. By using the symmetry, the area above the x-axis and below the x-axis are same for A1 and also A2. So we just calculate area above the x-axis. That means we calculate the area on the first quadrant and we just multiply it with 2 to get the complete area because of symmetry. So let's calculate. So A1 is given by 2 into, why multiply with 2? Because we just calculate the area above the x-axis, that is area on the first quadrant, and then we multiply it with 2 to get this entire area, entire shaded region. Okay. So 2 into def integral from 0 to a root a root x dx. So how we get this? So what is the formula for this def integral? We want to find the area from vertex to the lattice rectum. So if we integrate with respect to x, so the lower limit is x is equal to 0 and upper limit is x is equal to a for area region A1. Okay, then formula is lower limit to upper limit def integral fx dx, that is y dx. And what is the value of y? Y square is equal to 4ax, so we get y is equal to plus minus root under 4ax, that is plus minus 2 root under a root under x. And we consider the first quadrant, so we take the positive one. So y is equal to 2 root a root x. So this area is given by 2 into 0 to a 2 root a root x dx. Okay, so just take a thin strip, thin rectangle of width dx and whose height is given by y, that is 2 root a root x. And when we integrate from 0 to a, we get the area of the region on the first quadrant from 0 to a under the curve y square is equal to 4ax and bounded by x-axis, and the x is equal to 0 and x is equal to a. Clear? And when we multiply it with 2, we get the area A1. That is equal to 4 root a into 2 by 3, integrate root x, 2 by 3, x 3 by 2 from 0 to a. Upper limit is a and lower limit is 0. So when we apply the second fundamental theorem of integral calculus, that is when we get the antiderivative, we just find the difference of the value of antiderivative of upper limit minus the value of antiderivative function at lower limit. So we get 8a square by 3. So 8a square by 3 is the area of the region A1. Okay, so now we calculate A2. So A2 is equal to, so A2 is the area bounded by the region, bounded by the line x is equal to a, the line x is equal to 2a, and the curve y square is equal to 4ax. So here limit of x is from a to 2a. So we find the a2 as 2 into, we multiply 2 because we only calculate the area above the x-axis, that on the first quadrant. So we multiply it with 2 due to symmetry, because the area on the first quadrant and the fourth quadrant is same. So we only need to calculate the area on the first quadrant and multiply it with 2, we get the A2 area. Okay, so A2 is equal to 2 into def integral from a to 2a y dx, and y is equal to 2 into root a root x. We get this from equation y square is equal to 4x. And when we integrate this, we get 4 root a into 2 by 3, x 3 by 2, upper limit is 2a and lower limit a, and when we apply the upper and lower limit, we get 8a square by 3 into 2 root 2 minus 1. That is your area A2. Okay, and since A1 is 8a square by 3, so when we take A1 by A2, that is 8a square by 3 by 8a square by 3, 2 root 2 minus 1, 8a square by 3 is cancel out. We only left with 1 by 2 root 2 minus 1. And when we multiply the numerator and denominator by 2 root 2 plus 1, by 2 root 2 plus 1, we get 2 root 2 plus 1 by 7. Okay. So this is the required answer. Next question. The area of a smaller segment cut off from the circle x square plus y square is equal to 9 by x is equal to 1 is options 1 by 2 9 sec inverse 3 minus root 8, option B 9 sec inverse 3 minus root 8, option C root 8 minus 9 sec inverse 3, and D none of this. So there are two curves. First is x square plus y square is equal to 9. This is a circle with origin at center at origin 0 comma 0 and radius is 3. So this is a circle with center at origin and radius is 3. So at first draw the circle. Okay, and then draw the line x is equal to 1. So we just need to find the area of smaller segment, not a bigger segment, smaller segment, that is we make by this line on the circle. Okay, so first draw the figure and then find the limit for x where we can find the differential where we can integrate to find the area. And remember, this is the area between two curves. Okay, so what is the formula to calculate area between two curves by using definite integral? So just recall and try to solve. Okay, let's solve. So correct answer is option B, that is 9 sec inverse 3 minus root 8. Let's solve. So this is circle, x square plus y square is equal to 9 and x is equal to 1, the line. Okay, so how we calculate this? We don't even need to apply the the formula of area between two curves. Okay, so how we can calculate this? Circle with center at origin 0 comma 0 with radius 3. So 3 comma 0 and the line x is equal to 1. So this is the smaller segment cut off by the line x equal to 1 on the circle. From the circle, x square plus y square is equal to 9. So the set region is required region. Let's consider it as A. So this A is given by 2 into, now we multiply it with 2 because we only calculate the area on the first quadrant and multiply it with 2 to find the area on the fourth quadrant due to symmetry. Okay, how we calculate the area on the first quadrant? So 2 into, what is the range of x? So x varies from x is equal to 1, the line is x equal to 1 and another line is x is equal to 3. So this area is lies between x equal to 1 to x is equal to 3 and the curve is x square plus y square is equal to 9 and the x axis. This is the bounded region. So this is given by 2 into integral from 1 to 3, line x equal to 1 to x equal to 3. So 1 to 3 root under 9 minus x square dx and this is y dx. So how we get this? X square plus y square is equal to 9. So y square is equal to 9 minus x square. So y is equal to plus minus root under 9 minus x square. And we take a positive one because we calculate the area on the first quadrant. So 2 into definite integral from 1 to 3 root under 9 minus x square dx. Okay. And this is your special form. We know the formula of indefinite integral for this function and that is x by 2 root under 9 minus x square plus 9 sine inverse x by 3. Okay, so we just take the 1 by 2 common because 1 by 2 is a constant. So 2 into 1 by 2 x into root under 9 minus x square plus 9 sine inverse x by 3. Now upper limit is 3 and lower limit is 1. So apply the limits. So first take 3 and then 1. So we get 9 pi by 2 minus root 8 minus 9 sine inverse 1 by 3. Okay. That is 9 pi by 2 minus root 8 minus 9 sine inverse 1 by 3. So when we take 9 common, so we get 9 pi by 2 minus sine inverse 1 by 3 minus root 8 and pi by 2 minus sine inverse 1 by 3 is equal to cos inverse 1 by 3. That is the formula, 9 cos inverse 1 by 3 minus root 8 and cos inverse 1 by 3 is sec inverse 3. So we get 9 sec inverse 3 minus root 8. Okay, this is the required area. Next question. The ratio of the area bounded by the curve y is equal to cos x and y is equal to cos 2x between x is equal to 0 to pi by 3 and x axis. Okay. So we have to find ratio of the area. So we first find the, let's consider area 1, that is the area bounded by the curve y is equal to cos x and the line x is equal to 0 and x equal to pi by 3 and x axis. And consider the another area as A2, that is the area bounded by the curve y is equal to cos 2x between x equal to 0 to pi by 3 and x axis. And just take the ratio. So which option is correct? A, root 2 is to 1, option B 1 is to 1, option C 1 is to 2, and option D 2 is to 1. So let's find. Correct answer is option D, that is 2 is to 1. How we get this? So A1 is the area bounded by the curve y is equal to cos x between 0 to pi by 3 and x axis. So this is given by x varies from 0 to pi by 3. So def integral from 0 to pi by 3 y dx, y is cos x, so cos x dx. What is the integration of cos x? That is sin x. So sin x, upper limit is pi by 3, lower limit is 0. So apply the limit. Sin pi by 3 is root 3 by 2 and sin 0 is 0. So we get root 3 by 2. Second area, that is area 2, we represent by A2. And this is the area bounded by the curve y is equal to cos 2x between 0 to pi by 3 and bounded by the x axis. So this is given by 0 to pi by 3 y dx, y is cos 2x, so cos 2x dx. When we integrate it, we get sin 2x by 2 from 0 to pi by 3. Apply the limit, we get root 3 by 4. Okay. And when we take the ratio of A1 and A2, so A1 is root 3 by 2, A2 is root 3 by 4. So root 3 by 2 by root 3 by 4, root 3 cancel out, we get 2 is to 1. Okay. So option D is correct. Next question. The area bounded by the curve y is equal to fx, x-axis, and the line x equal to 1, x equal to b is root under b square plus 1 minus root 2. For all b greater than 1, then fx equal to, options are option A root x square plus 1, option B root x plus 1, option C x by root under x square plus 1, and D none of this. Okay. So we have to find the area. We have to find the function fx. Area is already given. The area bounded by the curve y is equal to fx and the line x equal to a to b is root under b square plus 1 minus root 2. So area is already given. We have to find that function. Okay. So how we can find this? Correct answer is option C, that is x by root under x square plus 1. Let's solve. So in the question there is given that is area bounded by the curve y is equal to fx, x-axis and the line x equal to a, x equal to b. So this is given by the def integral from 1 to b fx dx, and this is equal to root under b square plus 1 minus root 2. We have to find fx, and to find fx, what we do? We just differentiate this with respect to b. Okay, so apply the Leibniz rule. So when you apply the Leibniz rule, we get differentiation of this 1 to b with respect to b, 1 to integration 1 to b fx dx. So that is equal to fb, because differentiation of b with respect to b is 1 and differentiation of 1 with respect to b is constant, so we get 0. So we get 1 into fb, so we get fb is equal to, and then differentiation of the right hand side with respect to b, we get 2b by 2 into root under b square plus 1, that we apply the chain rule for all b greater than 1. Now 2 to cancel out, so we get fb is equal to b by root under b square plus 1. Change the variable b to x, we get fx is equal to x by root under x square plus 1. So to solve this question, we just need to know what is Leibniz rule. We just apply the Leibniz rule. Now next question. If the ordinate x is equal to a, divide the area bounded by the curve y is equal to 1 plus 8 by x square, x axis and the coordinate x equal to 2 and 4 into two equal parts. Then a is equal to. Okay. So there is a curve y is equal to 1 plus 8 by x square. And another information is the line x is equal to a, divide this area. Which area? The area bounded by this curve x axis and the ordinate x equal to 2 to 4. So if you draw this figure, so from the line x equal to 2 to x equal to 4 and the area bounded by this line and the curve y is equal to 1 plus 8 by x square, the line x is equal to a, divide this area into two equal parts, then what is the value of a? 8, 2 root 2, 2 or root 2. Okay. So correct answer is option B, that is 2 root 2. Let's solve. So just draw the graph. Just we know how we draw the graph. We know the curve tracing. So curve is y is equal to 1 plus 8 by x square. This is the curve. And there is a ordinate x is equal to 2. So the point M, that is 2 comma 0, and the line x equal to 2. And the point N, which represents 4 comma 0, that the ordinate x is equal to 4. And the ordinate x is equal to a, divide this area into two equal parts. So the line CD divide the area AMNB into two equal parts. Okay. So the area of the region AMNB, the entire region, is given by the definite integral. So from the ordinate x equal to 2 to 4, fx dx, y dx, and y, the value of y is 1 plus 8 by x square. So from the definite integral from 2 to 4, 1 plus 8 by x square dx. Okay, so just integrate this and find the value of this definite integral. So integration is x minus 8 by x. So when we apply the limit, that limit are 4 is upper limit, 2 is lower limit, we get 4. So 4 is the area of the region A, M and B. Okay, now the area of the region ACDM. So in this region, we find the area bounded by the curve y is equal to 1 plus 8 by x square, x axis, and the ordinate x is equal to 2 and x is equal to a. So now we integrate from 2 to a. Okay, so this area is definite integral from 2 to a, 1 plus 8 by x square dx, and that is equal to x minus 8 by x from 2 to a. And when we substitute these limits, we get a minus 8 by a minus 2 minus 8 by 2. And as it is given in the question that the ordinate x equal to a, divide the area in between into two equal parts. So this value must be equal to 2, that is 4 by 2. Okay. So when we solve this, a minus 8 by a minus 2 minus 8 by 2 is equal to 2, we get a is equal to plus minus 2 root 2. We get a quadratic equation, and when we solve that quadratic equation, we get the value a is equal to plus minus 2 root 2. Okay, so we get a is equal to 2 root 2. Okay, as a is positive. Clear? Now next question. Let the straight line x equal to b divide the area enclosed by y is equal to 1 minus x whole square, y is equal to 0 and x equal to 0 into two parts. Similar type of question. So the straight line x equal to b, divide the area enclosed by this curve y is equal to 1 minus x whole square, y is equal to 0 and x equal to 0 into two equal parts. R1 from where the x lies from 0 to b. That is, x is greater than equal to 0 and less than equal to b. And R2 region is the region where x greater than equal to b and less than equal to 1, such that R1 minus R2 is equal to 1 by 4. Okay. So the line x equal to b divide the area into two parts in a such a way that R1 minus R2 is equal to 1 by 4. Then what is the value of b? Options are 3 by 4, 1 by 2, 1 by 3 and 1 by 4. Okay. So correct answer is 1 by 2. Let's figure out. So the curve is y is equal to 1 minus x square. This is the parabola, shifted parabola, whose vertex is 1 comma 0. Okay. The line x is equal to b divide this area into two parts. First is R1 and R2. R1 which lies from x equal to 0 to x equal to b, and R2 is lies from x equal to b to x equal to 1. Okay. And the relation is R1 minus R2 is equal to 1 by 4. Then what is V? So we have given R1 minus R2. So when we apply the formula of definite integral to calculate this area, so R1 is given by x varies from 0 to b, y dx. So y is 1 minus x whole square dx. So 0 to b, 1 minus x whole square dx minus from b to 1. So b to 1, 1 minus x whole square dx. Okay, to calculate R1, we take the limit from 0 to b, y dx, and to calculate R2, b to 1, y dx. That is equal to 1 by 4 given. So just simplify, find this value of definite integral, integrate it, apply the limit, we get 1 by 3 minus 2 into 1 minus b whole cube by 3, and this is equal to 1 by 4. And from here we get 1 minus b whole cube is equal to 1 by 8. And when we solve this for b, we get 1 minus b whole cube is equal to 1 by 8. We can write 1 by 8 is 1 by 2 cube. So we get 1 minus b is equal to 1 by 2, where we get b is equal to 1 by 2. Okay. Clear? So in today's lecture, we discussed about area under a curve, how we can calculate if there is a curve and the area is bounded by the curve and the x-axis and ordinates x equal to n x equal to b, then how we can calculate this area by using definite integral, and also how we can calculate area between two curves. Okay, if there is two curves, then how we can calculate this area by using definite integral. And after that, we practice some question based on area under curve. Okay. Any doubt? Okay then. Thank you. Hello students, in today's lecture we are going to learn about waves and this is theory part second. Alright, this is our disclaimer. So in today's lecture students we will discuss first reflection and transmission of waves. Then we will study standing waves. After that we will discuss standing waves in string. Okay, then we will talk about standing waves in organ pipes, then open organ pipes, after that closed organ pipe, then we will study beats, and last we will see tuning fork. Okay, so these are the concepts which we will cover in today's lecture one by one. So students, our first concept is reflection and transmission of waves. So here question arises, what is reflection or what is transmission of waves? So we can say when sound waves strike the boundary between two media, some part of them reflects back into the initial medium and the remaining part of the sound energy is partially absorbed. It means the material consumes it and the partially transmitted. Okay, it means some part is reflected, some part is consuming by the material, and the some part is transmitted. So upon transmission the sound wave enters the second medium. Okay, now how much sound will be reflected? So absorbed and transmitted, these three things occurring here. So we can say uh, sound will be reflected, absorbed and transmitted. That depends on the properties of the media. Okay, if we talk about an example, so we can say if there is a boundary of a hard surface, let's assume it, such as a wall. Okay, then after striking that wall, a larger part of the sound energy will be reflected. But if the boundary is a soft material, then the soft material absorbs more sound energy. Okay, next is standing waves. How are the standing waves formed? So we can say a standing waves is formed when two progressive waves possessing the same fundamental characteristics interfere with each other. These two individual progressive waves must have the same frequency and thus the same wavelength and the same speed, but they must be traveling in opposite directions within a boundary medium. So the superposition of these two waves results in a standing wave, okay, that appears to remain in a fixed location rather than propagating through the medium. So let's assume uh, there is an incident wave that is moving in x direction. Okay, so in that case what will be the wave equation? So we can say wave equation will be y1 equal to a sine omega t minus kx. Okay, y1 equal to a sine omega t minus kx. So from this wave equation it is clear that the direction of wave along positive x axis. Yes or no?
and the reflected wave as y2 equal to a sine omega t plus kx. So y1 is incident wave, y2 is reflected wave. Okay. So when these two waves having same magnitude, same amplitude, frequency, and wavelength superimposed while traveling in opposite directions, then due to superposition, a standing wave is formed in which there is a no energy propagation. So when we add these two waves, y1 and y2, then y becomes, we can write y equal to y1 plus y2. And we know the value of y1, that is a sine omega t minus kx. And we also know the value of y2, that is a sine omega t plus kx. So when we add both, so y equal to a sine omega t minus kx plus a sine omega t plus kx. Okay. So on solving this, we get y equal to 2a cos kx omega t. This is our standing wave equation, in which this 2a, look at here, 2a cos kx part is the amplitude of the standing wave. Okay. And sine omega t represents the changes occurring with time. That is the oscillations of the particle. Okay, everyone. So the resultant wave does not represent a progressive wave. This is equation of a standing wave. Okay, in a progressive wave, the terms kx also comes with omega t. The amplitude of standing wave is 2a cos kx, and the amplitude of progressive wave is a. Okay, clear? Now we will understand how standing waves form in a string. So consider a string of length L and both ends of this string are fixed. Okay, that is clamped at its ends. So the tension on this string is capital T. All right. Now we have given the string is given a string a slight displacement. So due to which the particles of string will start oscillating in a direction perpendicular to the propagation of the waves. So the speed of that transverse wave is v equal to under root t by mu. Okay, where mu is the mass per unit length of the string. Okay, everyone. Now we will discuss different modes of vibration in the case of stretched string. So if both the ends of a string are fixed, then nodes are formed at the ends. Okay. So suppose a wave traveled, hit the boundary and reflected back. When this happens, in that case, we observe that standing waves are created. Now we need to understand how these waves are formed. Now assume that only one antinode A forms at the center and the string vibrates in only one segment. Okay. So the string takes this in a form. This means you applied a vibration, but the vibration that went like suppose this. Okay. So here both ends are fixed. So here only one antinode A is formed at the center and the string vibrates in one segment only. So it is called fundamental mode. Okay, and the length, look at here, length from this end to this end is capital L. Okay, or we can say L equal to lambda by 2. Here we assuming the wavelength is lambda 1, so it will be lambda 1 divided by 2. Okay, we had calculated the wavelength, that is lambda 1 equal to 12. We knew the length of the string and also the shape that was forming on it. So when this type of shape forms on the string, then it oscillates with a frequency, and we call it the frequency of fundamental mode. So the frequency of vibration in the fundamental mode will be, we can write here, frequency of vibration in fundamental mode, v equal nu equal to 1 upon 2l under root t by mu, this one. Okay, 1 upon 2l into under root t by mu. So here mu1 represents the frequency of fundamental mode of the standing wave in the string. Okay, so this fundamental mode is also called the first harmonic. Clear? It is also known as the fundamental frequency of first harmonic. Now if the string vibrates in two segments, okay, look at here, the total length is L and there is a two antinode, this one maximum displacement and one node. Now if the string forms such a shape, then the progressive wave that was established went like this and then reflected back from here. Okay, so amplitude of the wave and the frequency of the progressive wave and the wavelength of the wave should be this one, lambda 2 equal to L, and we can say total length is L. So these values for incident wave and reflected waves are equal, okay, due to which a standing wave will be formed here. So now look at this figure. We find a complete wavelength present at L, at length L. Okay, it means if we name this lambda 2, then lambda 2 is equal to L. So from here we can find the frequency of the second harmonic. This will be nu 2 equal to v divided by lambda 2, which is equal to 1 divided by L into under root t divided by mu, which is equal to 2 into nu 1. Okay, then we can say it is also known as first overtone or second harmonic. Okay, therefore we will call this the second harmonic because we can write nu 2 as 2 times the fundamental frequency. So this number decides which harmonic it is, and we will also call this first overtone. Okay, so as you might have seen in nomenclature in a building, the ground floor is called the ground floor, after that first floor, second floor, third floor, fourth, fifth, sixth. Okay, so the ground floor can be called the fundamental frequency, all right, and the frequency that comes after this can be called the first overtone, and and in the terms of harmonics, the fundamental frequency is the first harmonic, and then second harmonic, third harmonic, fourth harmonic, fifth harmonic, sixth harmonic, and so on. Okay, so if the same string uh, vibrates in this manner, meaning the three segments, look here, a, there is a three antinodes, a and a. Okay, a and a. So in three segments, look from here to here to here. Okay, uh, is half a wavelength. It means what? For half of the wavelength, we can say uh, from this point to uh, we can say from this point to this point. Okay, so this becomes 1 plus 1 by 2 lambda 3 is equal to L. Okay, so we can write 1 plus 1 by 2 as 3 by 2. Then we can write L is equal to 3 lambda 3 divided by 2. So the rest of the process is the same, and when we put this to find the frequency, then it will be nu 3 equal to V divided by lambda 3 equal to 3 times of nu 1, and it is called the overtone of the third harmonic. Okay, students, now if we want to generalize this, if we divide a string into p segments, okay, then the pth frequency will be pth frequency is equal to p divided by 2l into under root t divided by mu, which is equal to p into nu 1. All right, and nu 1 is our fundamental frequency. So which harmonic will this be? The pth harmonic. Okay, and what will be the overtone? So one will be the fundamental. After fundamental, the first, second and third overtones will come. This means whatever the number p is, the overtone will be one less than that. And if it is the sixth harmonic, then it will be the fifth overtone. So the one corresponding to p will be one less overtone. So that is the p minus 1 overtone. Okay, now we will study standing waves in organ pipes. There are two cases for this. One is an open organ pipe and the other is a closed organ open pipe. First, let's understand what organ pipe are. Basically, organ pipes are cylindrical pipes used to produce musical sound. Okay, so standing waves are formed in both types of organ pipes. If we consider an open organ pipe, it is open at both ends. This means it is open at one end and also open at other end. Okay, next we have a closed organ pipe. So it is closed at one end and open at the other end. Look at here. Okay, since an open organ pipe is open at both ends, antinodes are formed where there is a no rigid support. Okay, so maximum displacement occurs there, and where there is a rigid support such as a wall, a node is formed. So here there are two types of organ pipes, open organ pipe, second closed organ pipe. Okay, and we will discuss both. So first, open organ pipe. So let's proceed to the open organ pipe. So we will study about the fundamental frequency, first overtone, second overtone of an open organ pipe. Okay, so in an open organ pipe, an antinode always forms at the open ends. So the different modes of vibrations of air column in an open organ pipe are given below. So the first harmonic fundamental frequency L equal to lambda 1 divided by 2, because from here uh, to here it is lambda by 2, and this is the over length L. The formula for this is F equal to V divided by lambda. Okay, so here lambda is equal to 2L, so the fundamental frequency will be F1 equal to V divided by 2L. Okay, and this one is the node. Then second harmonic or first overtone, L equal to lambda 2. Why? Because from we can say from here to here, uh, it is lambda by 2, and from here to here again lambda by 2. Okay, meaning from uh, here it is a complete wavelength. Okay, and what is its length? So it is length is L, so L is equal to lambda 2. Okay, so f2 is equal to 2v divided by 2l. All right, now observe here what was our fundamental frequency. So f1 is equal to v divided by 2l. So if we want to write f2, we can write 2v divided by 2l. Yes or no? And what is v divided by 2l? F1. So what happened? F2 equal to 2 into F1, which means F1 was multiplied by 2. Therefore, when we multiply F1 by 2, it becomes the first overtone or second harmonic. That is why F2 is called second harmonic. Okay. Next is third one. When we consider the second overtone, which corresponds to the third harmonic, the shape of the standing waves appears as follows. This one. Okay. So this represents a one half wavelength followed by another half wavelength and a third half wavelength. Okay. So consequently, there are a total of a three half wavelengths. We can express this as 3 lambda by 3 divided by 2, which is equivalent to the length L. All right. Now we will see frequencies are present in an organ pipe. Okay. So in an open pipe, all harmonics are present. 1, 2, 3, 4, 5, all in this manner. Okay. It means if the first frequency is new one and the second will be 2 new one, then the third will be 3 new one, and the fourth will be 4 new one, fifth will be 5 new one, and so on. Therefore, we say that all harmonics are present in it. If you calculate the ratio of frequencies in the case of an open pipe, meaning it a new 1, new 2, new 3, new 4, new 5, new 6, when we calculate the ratio of all these, then it comes out to be 1 ratio, 2 ratio, 3 ratio, 4 ratio. Okay, and the ratio of their overtones comes out to be 2 ratio, 3 ratio, 4 ratio, 5 ratio, and in this manner. If we talk about the position of nodes, where we find nodes, then if you look at the node from any end, so the first node is found at lambda by 4, then 3 lambda by 4, then 5 lambda by 4. Okay, so position of antinodes from one end, so x equal to 0, lambda by 2, lambda, 3 lambda by 4, like this. So as we saw in the previous case, in the fundamental mode, this is our lambda by 4. Okay, this is a total lambda, this is a total lambda by 2, and from this end, when we look at lambda by 4, then a node is found here, and where was the antinode? Okay, so the antinode was at this end, look at here. So here antinode, so antinodes are formed. Okay, n here n1, n2, n1, and n2 and n3. Okay, and the length is lambda 1 by 2 and lambda 2, and then 3 lambda 3 lambda 3 divided by 2. Closed organ pipe. So in a closed organ pipe, a node is always formed, okay, at the closed ends. So the different modes of vibration of the air column in a closed organ pipe are shown below. This one. So this is our first harmonic node. All right, this one. L length is L lambda 1 by 4. So L equal to lambda 1 divided by 4. So its fundamental frequency will be F1 equal to V divided by 4L, where V is the velocity of the wave inside the closed organ pipe. And when we talk about the next frequency, then what will we what it be? So its name is a third harmonic. Okay, so the question arises that where did the second harmonic go? So when we discuss harmonic terms, we observe that the frequency of this vibration is expressed as a multiple of the first one. So our fundamental frequency is V divided by 4L. So L length is, it is 3 lambda 3 divided by 4, and frequency is 3V divided by 4L. Similarly for fifth harmonic, second overtone. Okay, so L equal to 5 lambda 5 divided by 4. So F5 equal to 5V divided by 4L. So we can also write it as 5 into F1. Therefore, because of this 5, we will call it the fifth harmonic. Okay. Next is closed organ pipe. So for this, our general formula will be that in closed organ pipe or odd harmonics are present, and their ratio is n1, n2, and n1, n3, and 5. Okay, 1 ratio 3 ratio 5, and so on. Ratio of overtones will be 3 ratio 5 ratio 7. The position of nodes from closed ends, x is equal to 0, lambda by 2, lambda 3 lambda by 2, 3 lambda by 2. Okay. So for antinodes, the value of x will be lambda by uh, 4, 3 lambda by 3 lambda 2 divided by 4, 5 lambda 3 divided by 4. Okay, these are the positions of antinodes. So if we look at some shapes of the standing wave in this panel, then this is the fundamental. This is for the fundamental. Okay, then this is for the third harmonic, and this one is for uh, third harmonic, fifth harmonic, specifically when we talk about a closed pipe. Okay, so now look at here, the nodes is at 0. Here 2 node is at 0. Okay, this means there is a difference of lambda by 2 between two nodes. So we can say there is also a difference of lambda by 2 between the two antinodes. Next is beats. So what are beats? When the frequency of two sound waves is almost equal or slightly different, it means their frequencies are close, not much difference, and their amplitude are also equal, and both waves are traveling in the same direction. And in a such case, when these waves superimpose on each other, the listener perceives the sound intensity at sometimes high, sometimes low. It means alternatively, okay, intensity is increasing or decreasing. So understand that two sound waves are moving in the same direction, both having the same amplitude. Then we hear beats, and this phenomena is completely different from standing waves. So in standing waves, two waves are moving in opposite directions. Their frequency, amplitude, wavelength are all the same. But when we get beats, two waves are moving in the same direction, okay, and superimposing. Then we get a rise and fall of sound, and this rise and fall of sound is called beats. So the number of beats formed per second is called the frequency of beats. Okay, so the number of beats formed per second, we know frequency of it. So now suppose there are two sound waves. One has frequency a new one, and the other has frequency new 2. All right. So if we superimpose both, then the frequency of beats can be new 1 minus new 2, or new 2 minus new 1. Okay. Therefore, it is written as generalized form new 1 minus new 2, mode of new 1 minus new 2. Okay. It means whether you take new 1 minus new 2 or new 2 minus new 1, whatever difference comes, that will be the beat frequency. Okay. So for formation of distinct beats, the difference between the frequencies of two superimposing nodes should be less than 10 hertz. So our perception of loudness is better correlated with the second level measured in decibel dB, and that defined as follows. So loudness is defined by 10 log 10 I upon I naught. Here I is the intensity of instrument or object producing the sound, and I naught is the reference intensity, which is the 10 to the power minus 12 watt meter square at 1 kilohertz. All right. Next is tuning fork. So the tuning fork is a metallic device that produces sound of a single frequency. So suppose there is a tuning fork whose frequency Na is given. It is struck together with another tuning fork whose frequency Nv is unknown, and x beats per second are here. So there are two possibilities to know frequency of unknown tuning fork. First, Na minus Nv equal to x, and this is equation first. Second, Nv minus Na is equal to x, let this is equation second. So we can find our true frequency of tuning fork B from a pair of tuning forks A and B. So in which frequency of A is known, and where x is the beats per second. So suppose B is B is loaded, its frequency decreases. Okay, so when tuning fork B is loaded, its frequency decreases. Okay, so there is a some cases. In this case, if x increases, then NB equal to Na minus x, and if x decreases, then Nv equal to Na plus x, where Nv is the frequency of tuning fork B and Na is the frequency of tuning fork A. Okay, and when B is filled, its frequency increases. If x increases, then Nv equal to Na plus x, and if x decreases, then Nv equal to Na minus x. So all these are both are different cases. All right. So let's see what we discussed here. First, reflection and transmission of waves, then standing or stationary waves, standing waves in string, then standing waves in organ pipes, then open organ pipe, then closed organ pipe, then beats, then tuning fork. Okay, tuning fork produces a specific pitch when stuck, generating vibrations that create a clear and sustained sound, often used for tuning musical instruments. Alright, so that's all for the today. Now we will solve some practice questions based on these concepts. So, students, are you ready for the practice questions? Yes or no? If yes, write in the chat box. And I expect answer from everyone. Okay? Now, students, we will solve some practice questions based on waves. Okay? This is our disclaimer. So, here we will solve some practice questions based on waves. So, the first question, in order to double the frequency of the fundamental mode emitted by a stressed string, the length is reduced to 3 by 4th of the original length and the tension is changed. The factor by which the tension is to be changed is what? So now we need to find the factor by which the tension needs to be changed. Okay, given options: option A 3 by 8, option B 2 by 3, option C 8 by 9, and option D 9 by 4. Okay, please solve this question and find out the correct option. Yes, please. Let's see who will solve this question. Yes, Karthik, Varsha, VK, anyone? Yes, please try to solve this question, everyone. Which one is correct? A, B, C, or D? A, B, C, or D? Okay. Anyone? Which one is correct? Tell me. Yes. VK, Varsha, Karthik. A. Okay. So the correct option is D. Okay. Let's see the solution. So let's assume its initial length is L. Okay. And if we're talking about the fundamental uh, mode of this string, then the shape of the standing wave is shown in the figure. Look at here. Okay. This one. So here a half wavelength will form over the entire length. L equal to lambda by 2. Now the frequency of this new we know 1 upon 12 into under root t by m. This is the frequency formula for a stretched string whose length is L, tension is T, and the linear mass density of this string is m. So this is how we calculate frequency. Now let's see that if we consider two cases here and divided their frequencies as nu 1 and nu 2, then the relation will be this one. Okay. So just substitute the values in the relation and you will be get the uh, nu 1 upon nu 2. So when we solving this, you will be get nu 2 equal to 2 times of nu 1, or we know L2 equal to 3 by 4 into L1. So just substitute the value. So it will be 1 by 2 equal to 3 by 4 into under root T1 upon T2. It means when we performing calculations, you will be get under root T1 upon T2 equal to 2 by 3. So T2 upon T1 equal to 9 by 4 when we squaring both sides. So T2 will be 9 by 4 into T1. Okay. Clear everyone? Next question. A granite rod of 60 centimeter length is clamped at its middle point and is set into longitudinal vibrations. So the density of granite is 2.7 into 10 raised to power 3 kilogram per meter cube, and its Young's modulus is 9.27 into 10 to the power 10 Pascal. What will be the fundamental frequency of the longitudinal vibrations? Okay, now we need to determine what will be the fundamental frequency of longitudinal vibrations of the granite rod. So when such a step occurs, we use the concept of waves that travel through solids or longitudinal waves that travel through a wire. Okay, so which option is correct? A, B, C, or D? Yes, which one is correct? Please solve this question, everyone. Yes, please solve. Which one is correct? Five kilohertz, 2.5 kilohertz, 10 kilohertz, or 7.5 kilohertz? 5 kilohertz. Anyone? Okay. Which one is correct? So the correct option is A, 5 kilohertz. Okay. Let's see the solution. So here, if we talk about longitudinal waves on a granite rod, then its waveform as on like this. Okay. So for this lambda by 2 will be equal to L. This means that half a wavelength is formed over the length L. So this means lambda equal to 2L. So and speed of the wave v is equal to the square root of Young's modulus divided by density. So v equals square root of rho y divided by rho. Okay. So frequency is equal to v by lambda. So you know uh, f equal to 1 divided by 2L into under root pi divided by rho. So just substitute the values and you will be get f equal to 5000 hertz. Okay. 5000 hertz. 5000 hertz means 5 kilohertz. All right. Clear, everyone? Yes or no? Clear? Any doubt? Okay. Next one. A pipe open at both ends has a fundamental frequency f in air. The pipe is dipped vertically in water so that half of its is in water. The fundamental frequency of the air column is now. So here we need to calculate the fundamental frequency in the remaining length of the air column. Okay. Given options: option A f by 2, option B 3f by 4, option C 2f, and option D f. So which option is correct? Please solve this question, everyone. After that, we will provide the solution of this question. All right, please solve. Which one is correct? Okay, A. So the correct option is D. Okay, let's see the solution. In the first case, we will consider an open pipe. Okay, so for the fundamental frequency, the wave will form in a such a way that at the open ends, an antinode is always formed. Okay, so in this forms over length L as shown in the figure. Look at, so this one is the antinode. All right, so length is L, so it will be L equal to lambda by 2. So rearranging this, you will be get lambda equal to 2L. So we know the formula of frequency V by lambda. So just substitute the value of lambda. So it will be F equal to V by 2L. And let consider this is equation first. Similarly, in the second case, water is filled up to the half distance. Look at here. Okay. So due to which the length becomes one only half. Okay. So now the difference is that for this wave, an antinode will form on this side and a node will form on this side. Okay, so due to this we can write that length is L by 2 and lambda by 4 wavelength is present in this length. Okay, when we dip a half of the length, half in the water, so lambda prime by 4 equal to L by 2. So when we rearranging this, you will be get lambda prime equal to 2L, and we know again the formula F prime equal to B divided by lambda prime, so V upon 2L. Okay, so let's consider this equation second. So from equation first, and we have F equal to V by 2L, and therefore from first and second we have F equal to F prime. Okay, so when the pipe is dipped vertically in the water, so that half of it is submerged and fundamental frequency remains the same as before. So D option is correct. Okay, next question. Third overtone of a closed organ pipe is in unison with fourth harmonic of an open organ pipe. The ratio of length of the pipes are what? Okay, so here uh, it has compared a closed pipe organ pipe and an open organ pipe. It is stated here that the third overtone of pipe closed open organ pipe is equal to the fourth harmonic of the open organ pipe. So we asked for the ratio of the lengths of the pipes. Okay, given options, option A 7 by 8, option B 3 by 4, and option C 5 by 7, option D 8 by 7. So which one is correct? Yeah, please solve this question. A, B, C, or D? So the correct option is A, 7 by 8. Okay, let's see the solution. So the word unison means two sounds have the same frequency. Okay, so the third overtone of closed organ pipe means seventh harmonic. Okay, so we know that uh, third overtone of a closed organ pipe actually seventh harmonic. So using this, in a closed organ pipe, only odd harmonics, first, third, and fifth, and so on, are formed. So after the fundamental frequency, it means first harmonic. The first overtone means third harmonic, and second overtone means fifth harmonic. So and third overtone means seventh harmonic. And in the case of open organ pipe, there is the fundamental and then first overtone, second overtone, and the third overtone, so on. So frequency third close is equal to nu for open. So just substitute the values for a closed organ pipe. Nu 3 equal to 7 into V divided by 4 LC, and for an open organ pipe, V4 nu 4 equal to 4 into V divided by 2 LO. So equating these, we get this one. So when we rearranging this, you will be get LO divided by LC equal to 8 by 7. So LC divided by LO is equal to 7 by 8. Okay, this means answer A is correct. Next question. Motion of two particles is given by y1 equal to 0.25 sine 310t and y2 equal to 0.25 sine 316t. Find the beat frequency. So here we need to find out what the beat frequency will be. Given options: option A 3, option B 3 by pi, option C 6 by pi, and option D 6. So which one is correct? This is very simple questions. Please solve this question everyone and try to find out the correct answer. Okay. Yes. Which one is correct? Anyone? Okay. Which one is correct? A, B, C, or D? You have to find out the correct one. Just you use the concept of beat frequency. You know the formula of beat frequency? Just apply here and you will be get the correct one. Okay, everyone? Please try to solve this one. So the correct option is B. Okay, let's see the solution. So we know the we have two equations, y1 equal to 0.25 sine 310t and y2 equal to 0.25 sine 316t. Okay, so from these equations we can calculate the omega. Okay, so comparing with standard equation, we have omega 1 equal to 310 radian per second, and we know the formula of frequency 2 pi f Yes, omega equal to 2 pi f. So omega f equal to omega upon 2 pi. So just substitute the values here. F1 will be 310 divided by 2 pi hertz. Similarly, we can calculate omega 2 by comparing the equation second with standard one. So it will be omega 2 equal to 316 radian per second. So again we here substitute the given values in the terms of in the formula of frequency. So f2 will be uh, 316 divided by 2 pi. So we have a two frequencies f1 and m2. Okay. So we know the formula of beat frequency fv equal to f2 minus f1. This is the slight difference between the two frequencies. Okay. So when we subtract the values f2 minus f1, we get fb. So fv will be 3 by pi hertz. Okay, everyone. This is a very simple question, direct formula based question. Just you need to compare the given equation with standard equation, and you will be get the omega, and then put the values omega into the frequency and find out the difference of frequency. You will be get the beat frequency. Okay. The next question: three sound waves of equal amplitudes have frequencies nu1, nu minus 1, nu and nu plus 1. Okay, they superimpose to give beat. The number of beats produced per second will be what? So here you have to find out the number of beats produced per second. Given options: option A 4, option B 3, option C 2, and option D 1. So which one is correct? Please try to solve this question, everyone, and find out the correct one. Which one is correct? All these are the formula based questions. These questions helps you to build your problem solving skills. Okay, and this helps you to do practice, to do more questions. So the correct option is C. Okay, given that the maximum frequency f max is equal to nu 1 plus 1 and the minimum frequency nu 1 minus 1. All right. So when we calculate beats, we look at the difference between the maximum frequency and minimum frequency. Okay, so we find the difference between those two. So here the frequencies are given as nu plus 1 and nu minus 1. Okay, so the maximum number of beats will be nu plus 1 minus uh, nu minus 1. Okay, so when we solve it, you will be get 2. Okay. Next question. Uh, there are two tuning forks, P and Q. Okay. When set vibrating, give 4 beat per second. If a prong of the fork P is filed, the beats are reduced to 2 per second. What is the frequency of P if Q is 250 hertz? Okay, so we need to find out the frequency of P. It's the options are option A 246 hertz, and option B 250 hertz, option C 254 hertz, and option D 252 hertz. So which option is correct? A, B, C, or D? You have to find out the correct one. Okay, please solve this question. After that we will provide the solution of this question. Okay, everyone, please solve. Yes, which one is correct? So the correct option is A, 246. Okay, let's see the solution. Now, here we will apply the concept of beats. As you know, the formula of beats is number of beats per second, that is equal to f2 mode of f1 minus f2. Okay, f1 and f2 are the frequencies of the tuning forks. So in the first case, mode of fp minus fq equal to 4. Okay, so the frequency of q is 250 hertz, so mode of fp minus 250 equal to 4. So from this, fp can be 254 hertz, or fp can be 246 hertz. So when the prong of p is filed, its frequency becomes greater than the original frequency. So, okay, if we assume that the original frequency of P is 250, 254, then on filing the frequency will be greater than 254. Okay, the beats between P and Q will be more than 4. Okay, but it is given that the beats are reduced to 2, therefore 254 is not possible. Therefore, the required frequency must be 246. All right, next question. So the question is 16 tuning forks are arranged in the order of increasing frequencies. Any two successive forks are give 8 beats per second. When sounded together, if the frequency of the last fork is twice the first, then the frequency of the first fork is what? Given options: option A 120 hertz, option B 160 hertz, option C 180 hertz, and option D 220 hertz. So which one is correct? A, B, C, or D? Please try to solve this question, everyone. Which one is correct? The frequency of the first fork is F, and the frequency of the last fork is 2F. So the correct option is A, 120 hertz. So let's look at its solution. In the given question, we have that 16 forks are arranged in the increasing order of frequency. Okay, and the frequency difference of each successive fork is 8 hertz. All right. So the frequency of the second fork will be n2 equal to n plus 8. So the frequency of the third fork n3 equal to n plus 2 into 8, which is equal to n plus 16. So similarly, this has to go up to 16, and we will get the frequency of the 16th fork. So n16 is equal to n plus 15 into 8, which is equal to n plus 120. So, and in the question, we are given that the frequency of the 16th fork is twice the frequency of the first fork. It means n16 equal to 2n. So, the frequency of the 16th fork is n plus 120, and so n plus 120 equal to 2n. So, n equal to what? N equal to 120. Okay, so the A option is correct. Okay, everyone. Any doubt? Any doubt here? Thank you for your attention. That's all for the today. In next lecture, we will discuss electrostatics. Okay, everyone. Thank you for your attention. Thank you. If you have any doubt, please ask. Yes or no? Any doubt? Anyone? Varsha, VK, Karthik? All right. Thank you. Thank you for your attention.